at the station now. Thank you very much.
The presentation is on. Is it visible, sir? Is it visible, sir? Not visible, sir.
It's not visible. It's not visible, madam. Yes.
No, it is visible.
Is it visible? Actually, sir, is it visible?
Yes, sir, it is visible.
Okay.
It is visible.
Yeah, thank you. Thank you.
Welcome to the international webinar on the modern trends in transportation system organized by NIT Silchar. So a very good morning to one and all the present here. Respected Director Sir, Dean Academic, Dean RC, HOD of Civil Engineering Department, and the TechCube 3 coordinator and all the distinguished speakers from the various parts of the nation and the international. Then during this hard time, we hope you all are safe and sound. There goes a saying, desperate time needs desperate measures. This is a testing and healing period for the world. They say there is always light at the end of the tunnel, and we do hope that we shall beat this pandemic situation and come out all the good with a positive and prosperous nature. NIT Silchar welcomes you to this 5-day webinar on the modern trends in transportation system, sponsored by TechCube 3, which aims to create a platform to enhance the information in the area of transportation system among researchers, faculties, and other transportation fraternities. This TechCube 3 sponsored webinar will help us to build the performance of the experts. They will speak all about their transportation system related issues. And this issues webinar will address to going to these issues related to the geometric design aspect, sustainable transport measures, surrogate safety measures, road safety audit, automated vehicles, deep learning techniques, biology of the binder, different type of imaging techniques explored in the asphalt mix, etc. Not only this, but various modern aspects of the transportation system will also be brought under the limelight in this webinar. So I would like to take the pleasure to give a brief introduction of all the proficient speakers who will grace the 5 days webinar session. Dr. Basudevan, the Associate Professor of Civil Engineering Department at University of Alaska Anchorage. Then Dr. M. Reddy, Professor from IIT Kharagpur. Dr. S. Velmurugan, Senior Principal Scientist at CSIR. Dr. Abhijit Maji, Associate Professor of IIT Bombay. Then Professor Muqaddas Abli Ahmed, Professor in Department of Civil Engineering, NIT Silchar. Then Dr. Ambika Kuiti, the Assistant Professor at NIT Silchar. Dr. Pranamesh Chakraborty, Assistant Professor at IIT Kanpur. Dr. Animesh Das, Professor from IIT Kanpur. Then the Suprava Jaina, Assistant Professor from NIT Silchar. Dr. Ashish Verma, Assistant Professor from IISc Bangalore. And Dr. G.D. Ransingcho, Associate Professor from IIT Roorkee. Dr. K.H. Lakshman Singh, Assistant Professor from NIT Silchar. Dr. Indrajit Ghosh, Associate Professor from IIT Roorkee. Dr. J. Murali Krishnan, Professor from IIT Madras. So, in this situation, we are very willing for us to witness of such huge and active participation from the participants across the whole country, as well as from some foreign nations. So almost a total of 830 participants from the various IITs, NITs, private colleges, and the abroad institutions like the BITS Pilani Dubai, so including researchers, academicians, transport planners, railway officials, army officials, etc., have successfully registered for this enchanting webinar. So it is indeed a matter of joy to see such a keen interest and encouragement from the participants. The 5 days webinar will be conducted by various renowned experts from various parts of the country and abroad. And we are very much lucky to have such a huge bunch of dignitaries on a single platform. We wish all the participants can acquire a good amount of knowledge and experience through this webinar session. So now I would request our chairman, HOD sir, to say a few words.
So, very good morning to all and everyone. Am I audible?
Yes, sir.
Respected Director Sir, Professor Shivaji Bandyopadhyay, TechIP Coordinator Dr. Sukumar Pati, my esteemed colleagues, and all the participants. It's a great opportunity for the department to organize this type of workshop, and as has been narrated by Dr. Quitty, for this program we have eminent speakers from reputed institutes from within the country as well as from abroad, as well as we have participants from different areas, from the industry, from the educational institutes. Number of participants also, it is, as mentioned by Dr. Quitty, it is more than 800 plus. So I believe next 5 days will be a rigorous interaction of the participants with the eminent experts from different institutes. This program will definitely be a great success, even though we are facing a lot of hurdles during these days COVID-19 situation. In spite of this COVID-19 situation, through this platform, Google Meet platform, virtual platform, this is the first of its program being organized by Department of Civil Engineering. I believe with the active participation of all my faculty members, the participants, and the eminent speakers, the program is definitely going to be a great success. With these few words, I wish this program again to be a grand success. Thank you very much. Ambika.
Yes, sir.
Yeah.
So thank you very much for your valuable speech. We are grateful for the time and effort you took to share your thoughts and experience. So now I would like to call the Dean Academic of MIT Silchar to say a few words.
Good morning. Hello.
Yes, sir. Very good morning, sir.
Yeah. So, respected Professor Shivaji Bandyopadhyay, Director NIT Silchar, Dr. S. Velumurugan from CRI, Professor Vinod Vasudevan from USA, Professor Ashish Verma from IISc Bangalore, our head of the department, Dr. P. Roy, our Dean RC, Professor M.A. Ahmed, other faculty members, and dear participants. So first of all, I am very happy to see that our civil engineering department have organized this program. Although most of the faculties are very busy in evaluating our end semester examination. So in spite of their busy schedule, they managed to organize this 5 days webinar. Now, regarding this topic, modern trends in transportation engineering, this is very much relevant for the present situation. All countries are still heavily dependent upon oil as their main resource of energy. However, oil resources are decreasing, forcing the people to look for alternatives. Again, with the increase of population and improved lifestyle, people are looking for automated transport system that are more fast, safe, and reliable. So I think our experts will deliver on these recent trends in research and development on these transportation systems, and our faculty members, research scholars, and all the participants will be benefited from this 5 days program. I thank the organizing committee of this webinar, and I wish a grand success of the program. With these few words, I conclude. Thank you.
Thank you, sir, for giving us an insight. It is an honor to hear from you. Now proceeding further, we would like to hear a few words from Professor Muqaddas Ali Ahmed, Dean RC of NIT Silchar.
Thank you, Dr. Kuti. Good morning to all, and good evening to Professor Vasudevan, respected Director, NIT Silchar, Professor Shivaji Bandavadde, Dean Academic, Professor A.K. Barbia, Head of the Department of Civil Engineering Department, Dr. P.J. Roy, Coordinator, TECIP 3, Dr. Sukumar Poti, Professor Ashish Burman from ISC Bangalore, Professor S. Velmurugan from CRRI, Delhi, Professor Vinod Vasudevan from University of Alaska, Anchorage, all the other experts of the webinar, my esteemed colleagues of NIT Silchar and other institutions, all the participants of the webinar, ladies and gentlemen. On behalf of the organizing committee and on behalf of NIT Silchar, I welcome you all to this 5 days international webinar at NIT Silchar. It is my privilege to be part of this international webinar as an organizing member as well. Thank you, everybody. Now, as the Dean of Research and Consultancy of the institution, I want to just present a brief research status of the institution. The institution is currently having more than 50 sponsored research projects, amount to about 20 crores. These projects includes various DST, various projects from DST, SCN, Spark, Imprint, FEAST, and many other national and international projects. At present, we have about 640 PhD scholars of the institution, out of which about 450 numbers are regular. The civil engineering department is having about 100 PhD scholars, out of which again 76 scholars are regular. Every year, the PhD degree awarding number is gradually increasing in NIT Silchar, and finally, in the last convocation, we have awarded 72 PhD degrees to the scholar. After the last convocation, we have already awarded 30 provisional degree to our PhD scholars, and another 30 is on roll. They are in various stages of evaluation. Even being the pandemic situation, the research in NIT Silchar has not stopped. Our PhD scholars are doing their various types of jobs, appearing various types of seminars, PhD evaluation process online. Even the defense are being conducted online. So we are trying our level best so that the research culture in the institution is never stopped, even maybe the pandemic situation. Though our student is not there in the campus, but they are doing everything from their home itself. Thank you, everybody. So regarding this Ambika Kuti Madam has already announced that about more than 800 participants we have, and we are initially we thought that we'll stream this only through Google Meet, but later on it has to be, we have to transfer to the YouTube channel streaming. So thank you as a organizing committee or as a coordinator, one of the coordinator of the workshop. I want to thank Director Sir and all my organizing committee member for their untiring work to make it successful. I wish the program a successful one. Thank you. Thank you very much.
Ambika, you are muted.
Yes, sir. So thank you very much for your delightful approach. Now I will request Secretary Coordinator Dr. Sukumar Pati. So just say a few words regarding this webinar.
Morning to one and all, except Professor Vinod Basudevan. For him, it's good evening. Respected Director Sir, respected Professor A.K. Barbuya, Dean Academic, Professor A.M. Ali Ahmed, Dean Research and Consultancy, Dr. Parthojit Rao, of the Department of Civil Engineering, distinguished for this webinar, my esteemed colleagues and dear participants. First of all, I must congratulate to all the coordinators, Professor M. Ali Ahmed, Dr. Ambika Kuti, Dr. Suprabha Jaina, Dr. K. Lakshman Sheikh, for their untiring effort to organize this webinar. This is just for your information that we did not organize any workshop or short-term training programs under TECIF 3 almost for a year at NIT Silchar. One of the reasons for that is less number of participants, especially from institute other than NIT Silchar, and also for getting difficulty of good speaker. Accordingly, our director sir has decided to organize international conferences with at least Scopus Index publications of the conference proceedings with manifold objectives, such as to showcase the research outcomes of NIT Silchar fraternity to the outer world, to have more interactions with researchers of other premier institutes. Now, during this pandemic situation, we have again decided to organize online workshop or short-term training programs under TECIF 3, and we are getting huge response from all across the country and other part of the globe. Further, we have taken a decision that 30 to 40% of the lectures of any online workshop or short-term training programs under TECIF 3 must be taken up by our internal faculty members. I do believe that with this, we can enhance the peer perception about NIT to a greater extent. I am sure that attending this workshop is a unique opportunity to all the participants to clear their doubts, to have a new idea on the modern trends in transportation systems. I do also believe that this workshop will become a platform to many participants to decide their future career in this area. As there is no scope for the extreme experts to spend their valuable times with the participants physically, I request all the participants to take the contact details of all the experts so that they can contact them for their collaborative works. Wishing a grand success of this international webinar. Thank you.
Thank you very much, sir, for your valuable speech. Now I may request Vinod Basudevan sir to share few words regarding this workshop.
Thank you. Thank you, everyone. I think, first of all, I'm extremely happy that NIT Silchar is taking a lead in making a webinar on this important topic. Because what I believe is that transportation is one of the field within civil engineering which is directly impacted with any changes in technology, because we are dealing with some consumer goods like car. Whenever there's a change in technology, we have to adapt to it. I mean, be it connected autonomous vehicles or autonomous vehicles, or maybe the changes in the materials, so on and so forth. And I think looking at the list of presenters, all are experts in the field, and I congratulate the organizing committee for making such an eminent list. I think I also will try to attend most of the session. Unfortunately, due to time changes, if you have recordings available, I may attend those, but at least I'll try to attend most of the first presentation. So that's okay. I think right now it's 8:30 here, so I think up to 10 o'clock I'm okay, but anything beyond that will be kind of difficult. With that, I'm not taking any more time. I think, again, thank you very much for having me here. And I will be talking to some of you in like 10 minutes time. Thank you.
Thank you very much, sir, for your valuable words. Now, may I request Velmurugan, sir, to speak something about this webinar.
Yeah. Thank you, Ambiga,
Thank you, sir.
for inviting me to share our thoughts. And first of all, I would like to thank the starting from the director of the Institute NIT Silchar, right up to the other dean and the other people for having taken an initiative to come out with the webinar covering the host of features in the transportation engineering field. So that's a very good aspect. Actually, went about in doing it. So actually, it's a 5-day thing. What we are expecting the participants to be on listening for continuously 3 hours. So that is the one thing which we have to make them keep them engrossed. I hope all the when we are going to speak about our be it our any project related thing or the other way sharing of our research thoughts. I hope we can make them keep them engrossed. Like I was just thinking at this point of time, 1 minute I'll just try to tell. Like regarding this initiative which is taken for a 5-day long thing. When we were done it in CTRG, which was spearheaded by Professor Ashish Verma and Professor Maurya. So that time there was 40 odd lectures. So every day people have to. He was the one who was mainly doing it. Ashish was just trying to listen to the different thoughts of different people who are there for the continuously 40 odd days, Monday to Friday. So I expect this 5-day workshop where we are going to do international webinar here. So the organizers can actually get benefited, and also we as the speakers, we will also get benefited to listen from the people during this 5-day thing, because it's sort of clear continuously to be there from today, starting from Saturday to Wednesday. I hope things will be good for the people to listen. And as I heard from Ambiga, around 830 participants have registered. That itself shows it's a good. We can pick up to. It's a good response is there, so we will be able to measure up to their expectations. Thank you, NIT Silchar, for having invited me to speak on this particular thing. Thank you.
Thank you very much for your valuable words, sir. Now, proceeding further, we would like to hear from Professor Ashish Verma from IS Bangalore. Sir, please.
Thank you. Thank you, Dr. Ambika. Hope I am audible.
Yes, sir.
Yeah, thanks for inviting me. I think it's a wonderful initiative. First of all, very good morning or very good evening, based on whichever time zone colleagues are joining. I have served in IIT Guwahati for 3 years, between 2006 to 9. So I always have a very special place in my heart for institutions in Northeast, and somehow I never came to NIT Silchar, but hopefully post COVID we'll have some opportunity to have such conference in NIT Silchar in future, and I would be very glad to come over and spend some time there and also have interaction with colleagues and students there. I'm glad, our director and IT Silchar, Professor Bandyopadhyay, and Professor Roy, head of the civil engineering. Of course, dear colleague, Professor Muqaddas Ali Ahmed. Um, uh, you know, Hello to all of you. I think the topic is quite interesting when I say modern trends in transportation systems. And if you really try to summarize what modern trends we are seeing, I would say three key elements or key things, and I'm sure many of the webinars that we'll have in next 5 days would cover some of these aspects. One, of course, is a growing focus on systems approach, and I'm glad that the title of the webinar series also says modern trends in systems. And this comes from the fact that we have moved away from supply-centric solutions or traditional engineering-based measures to more demand-based measures going in future, mainly from the point that there is a growing focus now and understanding about the externalities connected to transportation system and how we can minimize the externalities while also solving the core transportation system problems and issues. At the same time, there is a growing focus on how transportation impacts quality of life and livability. In fact, this coming January, when the TRB, the Transportation Research Board of US, is having their 100th meeting, the main focus of their conference is on how mobility contributes to quality of life. And so there's a growing understanding of that. And to address the systems approach and focus on externalities and quality of life, there is a growing interdisciplinary approach in transportation systems engineering, which is what is really, guiding and the whole research that is happening in transportation systems today. And as Dr. Velumurugan was mentioning, we did this 40-day long, webinar series in the month of May, June, continuously, and we have seen variety of presentations that focuses or brings out this interdisciplinary approaches. And when I say interdisciplinary approaches, we are gaining a lot from geospatial technologies on one side. On the other side, we are learning and taking inputs from communications, electronics, IT, image processing, and things like that. And on core sciences and other approaches like data sciences, deep learning, operations research, modeling and simulation, even consumer theory and economics. And so there's so much of interdisciplinary aspect in transportation system today, which is what is really the modern trend, I would say, in the real sense that we are seeing with this clear focus on systems approach. So I'm really hopeful over these 5 days, the participants will get a good flavor and mix of this modern trend that we are actually seeing in the transportation system. And I wish all the success for this webinar and a very fruitful and knowledgeable exchange throughout these five days. Thank you. Thanks for giving me this opportunity. Thank you.
Thank you, sir, for your valuable speech. Now, I would like to request our Honorable Director, Sir, Professor Sivaji Bandyopadhyay, sir, to address to the audience about this webinar.
Yeah, a very good morning to all my colleagues present here, and a late good evening to Professor Vasudevan. And warm welcome to all the participants who are on the YouTube channel also, besides all those of us who are here present. It's a nice program. The thing is that because within a span of, I think, almost 7 days, so the transportation engineering team in our institution, they have organized such a program. So it is like, say, what we say about transportation. It keeps civilization on the move, and the networking of people, networking of the different parts of the country. So the transportation section people, they have done a good job, first of all. Now to place NIT Silchar among our colleagues, that is in terms of the engineering ranking, in the last ranking. We are in the 46th position, and in the national ranking also we have moved into the top 100 for the first time. We keep research with a societal outlook as our research mandate or our focus. And with that objective, we have the Undergraduate Research Council, because so that the undergraduate students also they are motivated, and not only in the innovation but also in the research activities. And so because we understand that for the masters and the PhD students, they will be doing research, but for the undergraduate students also, so that if research is blended in the teaching learning process, so the whole contribution of the students and the faculties towards the society, so that becomes immense. Now, in our research focus also, we keep the thrust on the sustainable development goals of the United Nations. So be it the infrastructure, be it water resource, be it say the other activities that is which are related to the sustainable development goals. Now, coming to the topics that you are going to discuss during these 5 days of webinar. Say, one of my observation is that is because I am in the engineering education for a long time, and I've seen that the transportation engineering people, they seem to be sidelined, even in the civil engineering department, because the importance of the transportation systems or transportation engineering is not widely felt by the people from the other branches. For example, when our electrical department faculty, they work in the electric vehicles, so what contribution they are doing to the transportation system engineering, so that is not basically shared by both the communities. Similar things, in fact, within the civil engineering section, the environment section people, the people in the water resource, the people in the soil or the geotechnics, so the interrelationship between the communities, within the civil engineering and outside that, so that what some of the speakers were saying, that the field is basically truly interdisciplinary in nature. But that I think during these 5 days of program, so we'll understand that, and we'll try to share that with our colleagues, not only in NIT Silchar but in other places also. That is to keep the civilization on the move. All of us are making our contribution in that part. In fact, say some of the issues that we are thinking about, for example, in preparing the road, the materials, so the composite material, then how much you can bring it from the local region, that is so that the surface say remains stable for a longer time. Environment has a role to play. In fact, I was reading things like, say, having an elevated elephant corridor or an elevated railway track, which one is less costly, not only in terms of the cost, but also in terms of the environmental effects. So these are some interesting stories or situations so that are coming up. And so some of the most important things for not only for NIT Silchar, but other IITs and NITs in the country that are to happen, that is from the National Highway Authority of India. So memorandum of understanding, so very soon we are going to be, sign that, where a large stretch of the nearby national highway will be vested or associated with NIT Silchar, similarly with other NITs and IITs also. And the scholars and the students, so they will be getting the chance to give their, do their internship, do their assistance, do their survey, and they can have different kinds of support from the NHAI also. So that will truly mean that the teaching is not confined to the classrooms. It extends to the place where we can learn the most part of it. And before concluding, I should say that is the live streaming of the 5 days program on our, this is the YouTube channel from the official YouTube channel from NIT Silchar. And initially our plan was to inaugurate it on some other day on an international conference in the next week. But when the Professor Ahmed requested me, that is with so many participants, how we can manage. So we immediately decided that why not? Because YouTube channel basically is for the dissemination of information, what really goes along with the transport systems philosophy. So the participants who are on the listening to the YouTube channel, you are obviously, as you have become part of the history, because as an official channel of NIT Silchar, this is the first program that we are live streaming, and across the globe, across the country at the same time. I wish we will have more number of networkings, and so the result of that will not only be in terms of the directions in the modern trends in transportation systems, but also person-to-person networking. And what Professor Verma was telling, that is, all of you are welcome to be in NIT Silchar campus and when the situation becomes okay. Because that is the only thing that we are missing, the warmth in the campus. But otherwise, it is the most successful workshop or the webinar that we are going to happen, because the number of participants in each of these webinars are increasing day by day. Thank you to all of you, and have a good week ahead.
Thank you very much, sir, for giving us an insight. It is an honor to hear from you. Now, next, I would like to request Dr. Suprabhajana to address the vote of thanks.
Hello.
Yeah, good morning, Suprabhajana.
Good morning. A very good morning to Honorable Director, Sir, NIT Silchar, respected dignitaries, esteemed external resource persons present here with us today, and dear participants. And a very good evening to Professor Vinod Vasudevan, Sir. It is an honor and privilege for me to propose vote of thanks on behalf of the Department of Civil Engineering in the inaugural ceremony of MTTS 2020. We have been fortunate enough to be backed by our beloved director, Sir, Professor Sibaji Bandyopadhyay, Sir. I extend my heartfelt gratitude to you, Sir, progressing this webinar and sharing your vision and words of wisdom. I extend my heartfelt thanks to respected Dean of Academic Affairs, Professor A.K. Borbuya, Sir, and respected Dean of Research and Consultancy, Professor M.A. Ahmed, Sir, for enriching this function with your gracious presence. I extend my sincere gratitude to Professor P.J. Roy, Sir, HOD of the Department of Civil Engineering, for helping us out in organizing this webinar. I also wish to express my gratitude to the coordinator of TechWeek 3, Dr. Sukumar Pati, Sir, for extending his support in organizing this webinar. I would like to express my heartfelt gratitude to our esteemed resource persons who have taken time out of their busy schedule to share their knowledge and experience with us. I'm also grateful to all the distinguished participants for showing your interest to join this webinar from all over the country. Most importantly, conducting a webinar in this lockdown period is a challenge in itself. I therefore take this opportunity to thank the organizing committee of MTTS 2020, especially Dr. Naresh Babu sir and team for their relentless effort. I express my sincere gratitude to the coordinators of MTTS 2020 and the student volunteers for your hard work and dedication to organize this webinar. I hope that you will enjoy this webinar and have a fruitful learning experience as well. Once again, thank you one and all.
Thank you very much for being a part of yourself, making this part of this webinar. So thank you very much for in this inaugural ceremony, you are creating a huge success for this webinar. So moving to the inaugural ceremony, we would like to go our session. We would like to start in today's session. So that is a little bit 10 minutes late, 10-15 minutes late, but it's okay, we will manage somehow. So just starting with our first dignitary for today's webinar session, I would like to just give a brief biography of Dr. Vinod Vasudevan sir here. So, Vinod Vasudevan sir is an associate professor of civil engineering at the University of Alaska Anchorage. Before joining UAA in 2018, he served as a faculty of civil engineering at IIT Kanpur for more than 8 years. He has over 18 years of research experience in the areas of traffic safety, algorithms for leader data, neuralistic driving studies, transportation economics, transportation system planning, geographic information system applications, then traffic operations and highway financing. So he has published over 600 peer-reviewed articles, out of which 23 are journals, and Dr. Vasudevan has led over 20 research projects worth rupees million 2 million either as a principal investigator or as a co-principal investigator. Currently, he serves as a member of various technical committee at the TRB. And also, the Dr. Vasudevan is a registered professional engineer in the state of Nevada. So, may I request you to, sir, to present your session here in this webinar?
You stop present.
Yes, I should stop present.
Okay. Let me see. How can I present my screen? Do you know?
Yes, sir.
First time I'm using it.
Yeah, no problem, sir. In the rightmost corner, present now option is there.
Okay, I see that. Okay.
Yeah,
Your entire
just
screen. Okay.
yeah.
Okay.
Now you just click there, and your entire screen will be shared.
Okay, perfect. I think I got it.
Yes. Yes. Now you do the full screen. Yes. Now it is. Okay.
Yeah. Okay. Perfect.
Yes.
Okay. Good morning.
Yeah.
Yeah. Thank you again.
Very good
Again,
morning,
thank you
sir.
for- Yeah. Thank you. Thank you again for inviting me for this this webinar. I think it's exciting. And so, as Ambika mentioned, currently I am at University of Alaska Anchorage, but the work that I'm presenting today is based on my work in what I did in IIT Kanpur. So that's extremely relevant to Indian scenario. So it's not something which is not relevant. So I just want to make it a point. And in fact, all the work I'm presenting today are based on the work of my students, either PhD student or my master's student. So the title, there's a title, this actual title is Applications of an Instrument Vehicle to Study Road User Behavior. This is a slight change, which is all right. I just want to point it out. So this is the overall view of my presentation. So I will discuss an overview of traffic in India. I think most of us are familiar with that. Then I'll discuss why an instrument vehicle is necessary. And within the instrument vehicle, I have several equipments, but out of which I would specify LiDAR as one of the key component, which I used for my study. Then we'll discuss some of the details like how do you detect an object and how do you track an object and what are the ways in which you can collect data. Then I will explain 3 sample applications of this kind of instrumented vehicle, but it will be very brief because each of these driver behavior or pedestrian crossing behavior, each of the study itself is can be presented for an hour. So I'll not go into detail, but I'll give an overview so that the listeners will get an idea why we need, what are the advantages of having an instrumented vehicle. Okay. So this is the overview of Indian traffic scenario. I think you're all familiar with this. So I think if you look at both the pictures, both are extremely congested situation. But the first one on the left-hand side, what you see is more like homogeneous lane-based traffic, which is which you will be observing in most of the Western countries, or some other countries. But more important thing is that vehicle, if you look at, there are 2 things to notice. One is that the vehicles that you are seeing is more or less homogeneous. Of course, there are various vehicles like pickup truck, SUV, sedan, trucks, so on and so forth. However, predominantly they are all having very similar vehicular characteristics. Whereas in India, if you look at it, like most of the middle income countries or low income countries, the vehicle heterogeneity is extremely high, which means that we are occupying every inch of a road. although both are congested situation. This is what we see. So there's no, I mean, this is actual reality. We have seen or we have experienced through all these things. Now, why am I saying this? Okay, so if you look at properties, all the existing traffic models, be it simulation model like VSIM, Core SIM, all these models, they consider the traffic to be homogeneous and they expect the traffic to have good lane discipline. And because of these kind of properties, one-dimensional motion is required. I mean, that's only required because all we are talking about is a vehicle can accelerate and or it can decelerate. That's the main thing. And then based on that parameters, we'll be designing various traffic simulation models, including VSIM, Core SIM. All the simulation models that we use in India are based on this kind of assumptions. So because of since we are using one-dimensional motion, we are ignoring the vehicle present laterally. So all the existing models make these assumptions. If you look at Indian scenario, on the other hand, the vehicles are highly heterogeneous and lane discipline doesn't exist, more or less. Then there's high variability in road geometry also. You can see same road will change the width from maybe 6 feet to 3 feet without any warning. I mean, these are very common scenario. So which means that the traffic scenario is not really one-dimensional. So influence of vehicles present laterally is extremely important. For example, when you drive a vehicle, I don't know how many of you have driving license. If you drive a car, or I mean, mainly car, two-wheeler, at least we have more maneuverability. So we are not really worried about it. But when you're driving a car, you're always looking for three-wheelers, especially two-wheelers or auto rickshaw, to see when they will be doing. So which means that when you're driving in India, you're always worried about vehicles present laterally. Now the issue is that if you are still using, I think we are still using VSIM, Core SIM, many of the government project needs that we need to use some of this simulation software to validate the proposed plan. And VSIM and most of the models, they're all developed in either in Europe or in US, where vehicles are mainly homogeneous and they follow good lane discipline. For example, if you look at VSIM, they do a kind of a gimmick. I would say gimmick. The reason is they don't consider any other different type of vehicle, but they show some auto rickshaw. Auto rickshaw, although the image is as an auto rickshaw, but it's basically a car. If you look at the background or the property of that, and also they don't really consider lateral movement, which means that whenever we are doing a simulation, it may show it as a very efficient method, but the results may not be close to reality. So if you look at, I mean, this is only one slide where I will be discussing some of the theory, but it will be very brief. So if you look at some of the classic car following model, GM car following model is a classic example. This equation looks slightly difficult, but it's very easy. All you are saying is x double dot n1 is the acceleration. Acceleration of the vehicle is dependent on the relative speed and the space available, space gap between two vehicles. That's the only thing you need to know about it. So there are other models like psycho-physical model like Biederman model, which is used in VSIM, for example. Similarly, there are also rule-based models, fuzzy, discrete, multi-regime model, all these models. But all these models, none of them account for the Indian driving scenario, including the influence of vehicle present laterally. But unfortunately, since we don't have any proper simulation model which is developed in India or most of the low and middle income countries, we are still following it blindly and expecting the result to show the actual simulation. That's kind of a overview of why we need to collect more realistic data. Okay. Now there comes, how can we fix it? Of course, the first option would be to develop some kind of a traffic simulation software based on Indian scenario, which would be applicable not just in India, most of the South Asian countries, or most of the low-income countries, including maybe Africa, so on and so forth, because we are not alone. There are so many other countries which are having very similar experience. So how can we do that? So Basically, when you look at any of this car following model or traffic scenario, we are trying to understand what a road user would be doing, which means that we need to collect data, realistic data. So what are the ways in which we can collect realistic data? The options are, we can use a video data, which has been used extensively. Recently in the sense that over the last decade or so, we've seen several traffic simulators. That's another option. Third one is, this is a recent development, I would say in the last 5-6 years. That's when we started really exploring naturalistic driving data. I'll explain what that is. Okay, so video data, traffic simulator, or naturalistic driving data. Now, the advantages and drawbacks of video data. Of course, video data, it gives a lot of good images. But we all know that the issue is that depending on where the camera is kept, that gives only that range. So you can cover an intersection, or maybe with a wide angle camera, you can capture a wider angle or wider, longer distance. But data processing is easy. It's not easy. Although there are some advancements in the area of proper video detection, I'm sure that Professor Pranamesh Chakraborty will be talking something about video data day after tomorrow. But still, they are not efficient. At the same time, there are issues, there are serious challenges with respect to capturing distance information, distance or speed and all. Detecting an object is easier, but getting more information is difficult. Then comes traffic simulator. And we have India also, we have several traffic simulators. Those are good, especially when you're trying to study some of the user behavior. Let's say what will happen if something applies a sudden brake, or what will happen if a user is kind of distracted. Those kind of scenario, we can use traffic simulators. But there are evidences to show that when people are driving traffic simulators, the subjects tend to be less careful, which means that they know that nothing will happen. Even if you crash on an object, nothing will happen really. That's a reality. So people are familiar with that. So there are some questions with respect to the efficiency of applying stimulators for all applications. Of course, they have a lot of advantages in various other applications, but it is not a solution to capture realistic data for all scenarios. Then comes naturalistic driving data. What do you mean by naturalistic driving data? Which means that you are using some sensors in a vehicle and you're capturing, and the driver is driving without even realizing that, or even if he knows it, after some time, you forget about it because you have to drive. You have to drive, that's your main job. So you keep driving and then you capture the driving data. And there are a lot of studies conducted in US and in Europe. Those who are interested, you can look at 100 vehicle naturalistic driving data and studies, which is conducted in the US. And I'm not going to talk about it, but there's a lot of information, and you see how can we use the data, because that gives a lot of information about what a driver do under various scenarios. But the challenge is that it's extremely difficult. Video data is easy to collect. Traffic simulators are easier. Of course, they are costly, but they are also can be done. But naturalistic driving data means you need to have several vehicles, and they are extremely costly, and we'll discuss that. Okay, now, by using naturalistic driving data, we can collect and analyze data on Indian traffic more realistically. Okay. One of the best options is to conduct naturalistic driving study and collect data. So I think, okay, that's a mistake. Okay. So when you talk about an instrumented vehicle, or in order to do a naturalistic driving data, we need to have an instrumented vehicle. So there are three components of developing an instrument vehicle. First of all, we have to develop an instrument vehicle. That means you have to buy various hardware, and then you have to combine them together so that you have a hardware system. Second one is collecting and extracting data using naturalistic driving studies, which means that you are sending drivers and just for several hours so that you can capture what's happening when they drive. Then comes a third part, which is analyzing the collected data. There's a type of analyzing the collected data. Whatever you collect, you need to analyze, because I'll discuss why that is difficult. That's the most challenging. If you have funds, you can buy and develop an instrument vehicle. And once you have some drivers, you can collect data. But analyzing that is a challenge. Okay, now since we have to, when you are looking at naturalistic driving data, you have to capture the static and dynamic objects, geometric features, surface condition around the vehicle and driver's behavior, so that you can see what a driver is doing based on his surrounding. Surrounding includes other drivers. Okay, all these data need to be captured concurrently. Now, since four-wheelers and two-wheelers represent majority of road users, I know there are three-wheelers, but let's say we have majority we have two-wheelers and four-wheelers. So we propose to instrument one of each, but this study will show only the data from a four-wheeler. Now, to instrument a vehicle, what are the instruments we need? You can come with a list. I mean, based on, if you do a literature review, you would find several of them. So these are some of the sensors that we found based on our literature review. But then, based on the available resources and the objective of our study, we removed some of them from our list. So the final list included a LiDAR, OBD sensor. Then we had high resolution GPS. We had steering wheel sensor, accelerator sensor, brake sensor, camera, gear shift sensor. But although we had so many sensors, we mainly use LiDAR, GPS, OBD data, and camera data. Or most of the other sensors, at least we did not use for our most of the applications. This is an example. This is a picture of an instrument vehicle we developed. You can see that this is the LiDAR, this is a camera. All other sensors are inside the vehicle. This is a close-up picture of the LiDAR and the camera. This is LiDAR. And they have 4 cameras with wide-angle lenses installed so that it can capture 360-degree view. The reason was that LiDAR will give only point cloud. I'll discuss more about LiDAR in the coming slide. Now, we need to identify what object that is. So we used camera along with LiDAR to get a complete view of the object. Okay. So for data, when we had to collect some data, what we did is we used a set of drivers with various attributes, and these were actually drivers, and we did not tell them that we are observing them. What we told them was we were observing others. So we felt that they were okay, and after anyway, even you drive on traffic, after some time, drivers will have to drive the way they drive, because otherwise there'll be a lot of issues because they have habits which they have to follow. So data are collected while they drive naturally. So which means that we wait for an hour or two before we actually collect data. I'll also say so there will be questions about some biasness on this data, which I'll discuss later on. So now these instruments that we have in the vehicle, they collect the actions of various road users, including the driver of the instrumented vehicle, pedestrians, because this is capturing, LiDAR captures everything. So we can capture pedestrian, bicyclist, and drivers of other vehicles, which I'll discuss later on. I'll show a diagram how can we capture that. Now, once we have this data, these data are extracted in appropriate format for further analysis. So let's discuss LiDAR. Because LiDAR is the main sensor that we use. It was the most costliest piece of equipment. But if you look at LiDAR, it has a lot of applications. So so my presentation today is mainly on LiDAR. So what it does is it collects point cloud of the surrounding of the vehicle or surrounding of LiDAR at a high frequency. Since we used our LiDAR, it can capture up to 20 Hertz frequency, which means that the LiDAR is capturing the point cloud around the vehicle at every 1/20th of a second. In a second, you get 20 point clouds of the surrounding. So we used Velodyne VLP16 puck, which is the cheapest, most cost-efficient one, although that was costly at that time, but now they even reduced the price significantly. This is a picture of puck. You saw it on top of the vehicle. VLP16, number 16 shows that there are 16 channels. 16 channels means each channel will give will release a light ray. 60. Now, if you look at the most advanced Velodyne, you're talking about 128 channels. They're extremely costly. So we went with the basic version because we want to prove something. So that's where it is. The range is 100 meter. It can capture anything up to 100 meter. Accuracy is plus or minus 3 centimeter, which is excellent for most of the traffic engineering applications. And field of view, vertical is 30 degree and horizontal is 360 because it's capturing around the vehicle. But field of view is 30 degree in vertical. Again, if you go with advanced LiDAR, you can increase the field of view to maybe 50 degree or 60 degree. But for most of the application in transportation, I think 30 degree is sufficient. So this again, this is not a picture from our study. This is something I borrowed from, copied from website. I shown the source of this thing. It just shows you an idea what LiDAR can capture. Basically, it shows that it can capture point clouds of all objects. Forget about the cubes and some circles they developed. Those are actually process data. But using this, you can, using LiDAR data, you can capture anything within the vicinity of the LiDAR or the vehicle if you are deploying it on a vehicle. So let's look at this data from our study. So if you look at it, it's a video. So if you look at it, this is the top view. You can see something moving. You may not be able to see what they are exactly, but this is actually, this is a bus, this is a car, this is a pedestrian, so on and so forth. So what I will do is I will show this video, which the same view in a different angle. So when you look at a different angle, you can see that, okay, there's a pedestrian. This looks like an auto rickshaw, and there's a bus. There's another auto rickshaw, whatever it is. So you can get more idea. More than that, I mean, so keep in mind that these are not video. This is basically point cloud. We are capturing data at 20 hertz. Every 1/20th of a second, we are getting a snapshot of the surrounding, point cloud of the surrounding. And then we run it one after the other. You will get this kind of a video kind of a appearance. But they are not video. These are all point clouds. Okay. So this is kind of how the LiDAR data looks like when you have it. So the challenge is, okay, when you are driving on a vehicle, keep in mind that always the center of the image is the vehicle that you're driving, or the center is the LiDAR, basically, and it's capturing the surrounding. So when you're driving on a vehicle, there can be some road vegetation, there can be a truck, there can be a car, there can be bikes. These are the actual objects based on our observation. Now the question is, how do you capture them? Of course, if you look at the video, you see that you can have an idea what they are. But keep in mind that when you are looking at analyzing the data, we can't do anything visually. We had to develop algorithms. We had to develop programs to detect a car, detect a truck, or what a vegetation is. Now, a lot of data means processing would be very slow. So the challenges with the LiDAR data, although they give a lot of great information, the challenges are that detecting objects from the point clouds is challenging. Okay, I'm not talking about visually detecting, but if you want to write a program for that, it's not easy. Because first of all, shape of an object changes based on the distance and angle. For example, if you are looking at a bus from a distance, let's say if it's 0-degree angle, which means right in front of the vehicle, all you would see would be a rectangle, which would be representing the front face of the bus. Now, if it's at an angle, you'll see some portion of the side, and as it moves, the shape will change. So you can't really write a code and say that whenever you see this pattern, that's a bus, because that will not be working all the time. Now, occlusion is another challenge, which means that since it's a light rays, it will not go through an object, obviously. So if there's a taller, let's say you're seeing a bus, anything behind a bus will not have any data on that, because the bus obstructs all other view. Now, this is a major challenge. These things are, now the major challenge is that the point clouds do not have unique IDs, which means that, let's say you are in a nth frame, you are seeing a bus and you realize that that's a bus. Now, if you look at the next cloud, next point cloud, you don't know, let's say there are 3 buses. We don't know which bus you saw on the previous time slot because they don't have any unique ID. I think most of us have used GPS. GPS, the advantage of is that you can track each of them because you have a unique ID for each GPS. Now this LiDAR data, each point cloud is, you're starting each time frame, you start giving a random number, which means that you cannot see what object you detected in the next time frame. So that's a challenge. So tracking of the same object over various time period becomes difficult. I'll show some slide. It'll be easier, or it'll become easier what I'm talking. Now, coming to the traffic engineering challenge, if you want to really analyze this particular issue, what you need to do is you need to develop algorithms. Basically, you need to write programs to detect an object first, and then to track objects. Detection means you're detecting at each time frame that there's a bus or there's a car. There are 5 cars, 1 bus at this particular location. That's a detection. Now the question is, let's say you're seeing car A, and in next time frame there are 5 cars. So how do you see that whatever you detect as car A is the same car in the second time frame? So that for that you need to have an algorithm to develop track objects. So, I mean, as the first step, what we can do is we can remove unwanted point clouds. If you remember the previous slide, we had too many things like the bushes, which we don't need actually. When you drive, you're not really bothered about the bushes, or let's say some minor things on the pavement and all that we are not worried about. So we can remove some of them. That's the first step. We are filtering so that we can remove some unwanted point clouds. This is an example. So if you look at it, this is a video that we captured from this one. And you can see that truck, 2-wheeler and all. Now, after filtering, we can see the same thing. I hope that you can see that. See, there's a 2-wheeler which is going, overtaking. There's an auto rickshaw. This is a truck, so on and so forth. So when you look at it, so on a filtered data, again, this is a filtered data, okay? Raw data had so many things. So we removed some of the, we did apply some filtering algorithm. What do you mean by filtering algorithm? It's very easy, conceptually. For example, let's say our focus is detecting cars. Then we all know that, okay, car, the height is maybe 1 meter, and the width is 1.5 meter, let's say. So we say that anything within that size, that's the only thing we are interested. Remove everything else, all the point clouds. So that's the simpler way. I mean, I'm not giving the exact methodology, but just to give you an idea, that's what we mean by filter. So by doing that, what you will do is you will get only the points that you're interested. Again, filtering will be different for the kind of application you are looking at. For example, if you are interested in pedestrian, that filtering would be very different from the filter that you use for a car. Okay, so if you look at this is the unfiltered LiDAR data of pedestrian. Let's say we are studying pedestrians. So this is what an unfiltered LiDAR data looks like. But when you apply the filter, it removes all other things. Okay, so for example, more importantly, for analysis perspective, initially unfiltered one, it had 21,000, roughly 22,000 points. Whereas after you apply, it has only 45. You can keep in mind that this is only for one time frame. That means 1/20th of a second, you are dealing with 45 points, which is okay. Now, for a second, you are looking at 45 times 20, which is still manageable. It's not 22,000 times 20. So that's why the filtering is important. Now comes the second part, which is object detection. Excuse me. As I mentioned, since point cloud do not have unique IDs, we need to write programs to detect and track objects across various time frames. So we can use various data structures. I mean, such as quad-tree structure or various things. But what we used is, we used a clustering-based technique to detect and track objects. So first task is to detect objects using clustering. We used DB scan, and we explored various scanning methods, but finally we realized that DB scan is the best one to choose. So to implement DB scan, basically we wrote a program on Python. So basically DB scan, it takes only 2 parameters. So the concept is simple. I'm not going to go to the details of DB scan, but you can read it. There are a lot of information available online. What it does is, it is clustering an object based on 2 parameters. So what do you mean by cluster? It's a point. Basically, you're saying that, okay, when you say it's a cluster, all these point belongs to a particular object. So if you want to define as a one object, what you need is, it should be within a given range, that is the radius, and there should be a minimum number of points. Then only we can say that's an object. For example, if you're looking at a car, you know that the radius can be around 1 to 2 meters, because that's the shape, that's the width of the vehicle. Now, within 1 to 2 meters, you need to have some number of points. Then only you define it as a car. If it's only 2 points, then you say it's not a car within 2 meters. But within 2 meters, if there are 50 or 60 or 100 points, then you say that can be a car. So that's the kind of basic idea. But please read some other resources on understanding DB scan. So a cluster is formed if in a given EPS, points more than or equal to minimum points appears. So depending on size of the object, its distance and parameters, size of the object and its distance, parameters of the DB can fluctuate. For example, for our study, for a car, we used EPS of 1.25 meter and minimum points of 50. So this is a kind of a explanation of, this is a kind of a visualization of the clustering algorithm. So if you look at it, see, I want you to look at this one, estimated number of clusters and frame number. What you see is that at various time frame, this number of clusters that you observe will be different. Okay. Now, having done clustering, now in clustering, what we did is, at each time frame, we are estimating, okay, how many cars we have, how many pedestrians we have, so on and so forth. That's all the clustering does. Now, second stage is, we want to detect, we want to see, we want to track a particular vehicle or a pedestrian across time frames. So let's say that in nth frame, we have 3 objects. Let's say these are 3 cars, blue car, red car, and a green car. Let's say x1 n and y1 n be the coordinate of this blue car, and x2 y2 and n is the coordinate of red car, so on and so forth. Now that's for nth frame, and these are the coordinate of centroid of the cluster. Now when you look at n plus 1 frame, we know that x1 n plus 1, because n plus, previously it was nth frame, that's why we had x1 n. Now for n plus 1 frame, we are looking at x1 n plus 1 and y n plus 1. Now how would we know that the blue car that you detected, keep in mind that LiDAR doesn't give any color, it only gives point cloud. How do you know that this blue car is this, not this or this? Because it can be anything if you don't have any proper algorithm, because there's no unique ID. So what we did is, again, we have just a very development algorithm with just common sense. Of course, you can find various other algorithms. In our algorithm, what we did is, what we are saying is, if the position of this particular object is x1 n and y1 n, you know the speed at which the vehicle is moving. And we are talking about a very fraction of a second, like 1/20th of a second. In 1/20th of a second, what is the range in which this vehicle can move? That range we can estimate because it's traveling at a speed. And 1/20th of a second, this is the maximum distance the vehicle can move, either front, back, or sideways. So we define an area. You say that now within an area, this is the area that we defined. Sorry. This is the area that we defined. If you find a point object within this region, we detect that object as the same object as a blue car. And you can find some equation. Basically, this is nothing but you are multiplying with some parameters, speed and time. Here, time is 1/20th of a second. Sn is the speed of the vehicle, speed at which the vehicle is moving. So it's a very simple calculation. So we apply this algorithm. So by doing that, we are able to detect an object and track. Tracking is extremely important. Without tracking, we can use for any traffic engineering application. Okay. So again, this is exactly what I mentioned. I mean, so I'm not, you can go through that in the slide, but I explained already what they are. SI is the estimated speed, and K and L are empirical parameters. For when we analyze, we realize that K and L, when you make the value as 0.3, it works better. But again, it'll change based on various applications. Okay. Okay, now comes the question. What kind of data are we talking about? After going through all the theories, now we have an algorithm. We have algorithms to detect objects and track them. Track means we can track them across various time frames. Now the question is, what kind of data are we talking about? When we go out for data collection, we can capture data of the vehicle, user behavior of the driver of the instrument vehicle. But as I mentioned previously, let's say we are using total of 6-7 drivers across various time frames. Then of course you can say that, I mean, these drivers, since they know, even if you didn't tell them, they have sufficient intelligence to note that we are observing them, so they may be careful. Or since we have so many sensors in the vehicle, the drivers will be extremely careful in driving. It's possible. So that's one thing, but it may be biased. But more importantly, it can capture the behavior of other road users. For example, if you look at it, this is capturing location of surrounding like objects. It can be a kind of a bush on the road, or this can be a pedestrian. Similarly, this is capturing the location of this vehicle, this vehicle, this vehicle at 1/20th of a second. Okay, so this driver, he will drive the way he wants to drive. So that's 100% unbiased, because, and this guy will drive the way he wants. It's not really affected by anything. Even if you say that this driver is biased because this is your driver, but basically from our analysis, based on our analysis of data, we proved that the driver is driving normally. It's not biased. But still, if you have a question, we can capture data of other vehicle. Okay. So that's all about the instrumental vehicle setup. We can capture a lot of stuff. Now the thing is that, what are the uses of this? So keep in mind that this is capturing high frequency data of the location of objects, just locations. Now, using the locations of a 2 consecutive time frame, you can estimate relative speed. Again, why relative speed? Because the LiDAR is on a vehicle which is traveling at some speed. So the speed of the objects around it would be relative to the speed of the instrumented vehicle. So we are getting the location and relative location and relative speed. Now, using an OBD sensor, you know the speed at which your vehicle is driving. Now, if you know that speed of the vehicle, speed of your vehicle, then you know the relative speed, then we can estimate the speed of all other objects. Okay, so basically what we are saying is, by knowing the speed of the vehicle that you are driving, the instrumented vehicle, and relative distance, relative locations of all the objects around the vehicle, you can capture speed of all these things. Which is all we need for most of the traffic applications. Now, these data collected offer huge potential. So I'll be briefly going through 3 applications. One will say what kind of driver behavior we can do, pedestrian behavior, and how can we analyze some of the bicycle behavior. So let's look at the driver behavior. Again, this is one of the study that my PhD student did, as well as one of my master's student did. So they did different aspect of driving, overtaking. So the challenge in collecting, analyzing overtaking behavior is, I mean, people have been using mainly the video data. But you have to keep in mind that video is more or less stationary. Even if you are using a video on a vehicle, the problem is capturing the exact location of the other vehicles are difficult because you don't know from video extracting distance is extremely challenging. Okay, now this can be captured using LiDAR because it can be your instrument vehicle can be this vehicle which is overtaking, or it can be this vehicle, because then if this is the instrument vehicle, B0 is the instrument vehicle, then this is a vehicle which is unbiased because he doesn't know what you're doing. He just drives and overtakes the way he wants to do. Now, by studying everything, we can really capture how a vehicle overtaking is happening. Okay, so again, this is only a sample. I am only giving an example that we can capture overtaking. It can be any other thing like braking behavior or any other behavior. As long as we are capturing unbiased data, that's very extremely useful. So we capture driver behavior while overtaking and analyze the changes based on relative speeds of overtaking and overtaken vehicles. Again, these are some of the applications that we used. But all I'm saying is applications, what we used is not important. The important thing is that you can capture driver behavior of any vehicle within the neighborhood. Okay. Second one is pedestrian crossing behavior. Again, capturing pedestrian behavior is very difficult because they don't have any specific route, specific path. They can change anytime. You use video, all you can capture is if you look at most of the pedestrian studies, all they say is the starting time, end time of a crossing behavior. So by using that time, you're saying pedestrian took 10 seconds to cross. Yeah, that's useful. I'm not saying that's not useful, but using LiDAR, you can even capture more minute details. Okay, so what we did is we tried to study how the behavior of pedestrian vary on a mid-block crossing with respect to vehicle type. So what are the factors that affect the changes in crossing behavior? So this is one of the things. Again, this kind of data that you can not get using a video. So what we observed is that when in front of a car, what pedestrians do is, sorry, let me go back. Okay, so this is the speed at which, so let's say someone, this is in front of a car, walking speed, when they are starting the crosswalk, they are walking at a low speed. When they are at 40 to 60%, they are walking at a higher pace. And when they are getting close to completion of the crossing behavior, their speed is again decreasing. Now, whereas in front of a motorbike, people walk at very similar pace. Of course, you can ask question like, what is the application of that? There are a lot of application, especially when we study anything related to pedestrian behavior, because pedestrian safety is extremely important. We are killing so many pedestrians on road, so understanding their behavior is important. But I'm not going to discuss the other results and all, because that itself is one presentation to justify why this data are important. But at the end of the day, all I'm saying is using LiDAR-based instrumented vehicle, you can capture these details, which is not possible otherwise. We also now looked at the pedestrian path. How are they crossing? So if you look at it again, we expect pedestrian to walk on a straight line. Now, what we realize is that they're not walking on a straight line. This shows that someone, look at one of the things. So let's say he started here and he walked almost like 4 meters laterally before completing the road. Ideally, we expect them to walk straight, which means that they are spending more time on the road, which means that they are increasing their exposure. Again, they are walking 4 meters here and there. Then now the thing is that when you look at some of the measures like post-encroachment time and those kind of safety calculation, we'll be making error. Some of the classic situation when we compare with this, which would have been safe, which is not safe in India because people are not walking straight line. There could be reasons. Okay, again, we are discussing that in a paper that we are working on. And this is one of the work of one of my master's student. Okay, so what we realize is that maximum speed attained by pedestrians, which is not important. Okay, so these details are not important, but all I'm saying is you can capture these details using an instrument vehicle. So severity of an event increase with increase in speed. So those information we can get. Now, I just want to show 3 examples because one is about vehicles, second one is about pedestrian, and we also did some study on bicycle. The bicycle also, the objective was to see whether on Indian roads we are giving sufficient lateral gap. Lateral gap is extremely important because when you create some kind of a bicycle facility, if the vehicles are going close to bicycle, then bicyclists won't be feeling safe on road. So Canada has a specification. India doesn't have a specification, but Canada has a specification which says that there should be at least 1 meter lateral gap between the vehicles and the bicyclists. So we were trying to see whether we are giving that much lateral spacing on Indian scenario. Again, results show that the lateral gap is not influenced by speeds of passing vehicle, which is an interesting result because speed is not really influenced. Doesn't matter what speed they are, the lateral gap remain more or less same. But they're influenced by road classification and vehicle type. Vehicle type was more important than speed. We thought that when you are high speed, people may tend to go away from bicyclists, but no, that's not the case. They're only worried about, motorists are only worried about their safety. They're not really concerned about bicyclists. I understand that. The reason is we cannot blame them because if they give more lateral gap, there can be some other safety issue that they may face. So we understood that most of the times the minimum lateral gap is not maintained. Again, result is not important. The important thing is that we can capture these details using a LiDAR, and which is extremely important in Indian scenario because where we are trying to promote bicycling and walking, we need to understand how they do that. Now, other applications include, you can see a lot of application of LiDAR. So they have been used in US and China. They have been experimented to detect pedestrians at intersections. Again, they are not instrument on a vehicle, but they are instrument on a pole, and they capture the pedestrian data. And also, LiDAR has been used to detect animals near highways to warn drivers because animal-related crashes are extremely high in various places, including Alaska. So in Nevada, some researchers studied and they applied LiDAR, and they showed that LiDAR can capture image and they can warn drivers in advance so that they can avoid any crash. This is an image, again, I borrowed from some other researchers working this area. Other applications, I don't know if you are following connected autonomous vehicle technologies. LiDAR is one of the major sensor which is used in CAV technologies. So if you look at Google car or Tesla car, they are all using LiDAR as the main sensor because it can detect distance. So instrumental vehicle can enable faster CAV deployment. So what do you mean by CAV, which is connected autonomous vehicle? Again, forget about autonomous. That will take longer time for anywhere to deploy. But connected vehicle is a concept which is being deployed in US and most other European countries. Connected vehicle means that each vehicles are connected. Now, if you have the information of location and speed of all the vehicles within a neighborhood or within a region, it can make a lot of decisions. Now, one of the challenges is all the new vehicles we can easily make as connected because, yeah, all you need is some kind of a regulation and say that all the vehicles now onwards should have the CAV capabilities. Now, the problem is what will happen to the older vehicles? People will use it for 10 years, 15 years, depending on the life. So you won't change to the CAV technology. So now to include them in a CAV environment, you need some kind of a sensing technology. So LiDAR has potential to kind of do that. So there are a lot of applications of LiDAR. I'll tell you, in India also, connected vehicle technology will come faster. Autonomous, yeah, I don't think it'll come. It's already, at least in the next 2 decades or so. But connected vehicle has a lot of advantages that has nothing to do with autonomous vehicle. All it means is that all the vehicles are connected so that drivers as well as the system can take decisions which will improve the efficiency. Okay, So again, I would like to acknowledge my students. I mean, they did all the studies, and my role is just to present. So one is Validada, she is a PhD student. She is defending like very soon. Then there are 3 students who did master's study with me. Again, as I mentioned, all this work I'm presenting here are based on my work in the IIT Kanpur. With that, thank you. This is my email ID. So if you want to contact me, or if you have any questions, please you can email me. You have my email ID there. Thank you.
Thank you so much, sir, for such stimulating and thought-provoking speech. So there are a lot of questions in the chat box. So
Okay, I haven't looked at that. So if you have, where are those? Let me see. So I'll stop presenting. Okay. Yeah, because I use Zoom, and there are some other tools I use, but this is the first time I'm using YouTube presentations. I don't know where to look for. Okay, let's see. So where can I see the chat?
So there is another link. Yeah, in that YouTube link already I shared with you. So otherwise I can convey the questions to you.
Yeah, I think if you can have some of the major questions, I'll be happy to answer them. Because I'm still on the main page. Okay, so it's not, I haven't gone anywhere. Still, okay.
Okay. So one question from Akash Day.
Okay.
Is this system used in any of the cities in India?
Okay. Okay. So again, this is not a system which can be used. I don't know which system are you talking about, either LiDAR or CAV. Both are not deployed in India as of now.
Okay, another question from Anna AV. Is LiDAR can capture the speed of other vehicles and the geometry of the road?
Yeah. Okay. Yeah, so the geometry of the road, again, that depends on, again, keep in mind that this captures point clouds of the objects. So if the if the road has something, what do you call,
So another question is, shall we use this LiDAR sensor in autonomous car? Hello?
Ambika, I think sir is disconnected.
Yes, sir. So thank you very much, sir, for your wonderful speech.
You can ask the question directly to the speaker.
Okay. Other question you may ask through the email because he is not on the line actually. So you can ask directly to sir through the email.
You turn on the video. Just ask that. You turn on your video.
Yeah, already one attendance sheet already floated. Just go to there and just give your details as attendance. This is just for your information. So next participants are listed. These people. So
Yeah, sorry, I logged out myself. I know for some reason I logged out myself.
okay.
Can you hear me now?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
Sorry, I somehow it got closed. I mean, I don't know what.
No problem. It's okay, sir.
Yeah. Yeah. So the question was, I mean, about whether can we track. I don't know if you. How long was I out? I mean, did you hear anything? Any of my responses? No.
No, about for last 2 minutes you were about 2 minutes, sir. You were out of the connection.
Okay. So let me answer that question again. Yeah. So what I'm saying is, when you talk about the geometry, it's not easy. Geometry you cannot do based on the LiDAR only, because LiDAR only captures the physical stuff. Geometry is not something physical that LiDAR can capture. So what most of the companies like Google Car or Tesla, those kind of people, they use is also use GIS maps from background. That will give the geometry information, and LiDAR will only give the obstructions on the way. Okay, I'm just giving again. I'm talking in terms of layman's terms. I mean, I'm not going to details. Having said that, but the second question was, can you capture speed of the all the objects, all the other cars? Yeah. So the reason it can do, again, it won't automatically give. You need to do some calculation. That's what I showed in one of the slides. Keep in mind that LiDAR only captures locations of these objects at high frequency, which means at 1/20th of a second. 1/20th of a second will give relative location of various objects. If you get relative location of an object in 1/20th second, you can use simple math physics. I mean, x1 minus x2 by delta t. Okay, by using that simple equation, you can estimate the speed, relative speed. Now, once you know the speed of the vehicle, the instrument vehicle, and then you know the relative speed, then you can capture the actual speed. So that's an estimation. It's not an actual speed, but it's an estimation of the actual speed. But we did some experiments, and they are very good. They are very accurate. I mean, very close to. I mean, I would say within plus or minus 0.1 kilometer per hour. That's the accuracy that we got for our experiment. So we are very comfortable with that process. Yeah, Ambika. So next question, can you read?
Okay, so next question is, what is the extra cost required to upgrade a normal vehicle to an instrumented vehicle?
Again, yeah, okay. So instrumentation is something you are talking about. Again, instrumentation can be anything. I mean, you can, depending on how much money you have. But what we spend, I mean, right now LiDARs are very economical. Again, keep in mind that we don't need this kind of instrument vehicle for any of our day-to-day application. We are talking about some of the experiments that we are conducting. Okay, so LiDARs are recently, I mean, whatever we bought LiDAR, that time it was very costly. It cost us around 18 lakhs or something. But now it's very cheap. I mean, it's very cheap in the sense that I think you will get something for, I don't know the exact amount, but in US now they are only like $4,000. But so maybe it'll cost 4 lakhs because of the export fee, so on and so forth. Now, to me, I mean, the main challenge is not buying them, but data processing. You need, that's where the challenge is. So LiDAR can be bought easily, and then video cameras are very cheap. In fact, you only need these. Then OBD sensors are very cheap. OBD sensors, you will get something for 5,000 to 6,000 rupees. So it's nothing there. But the challenge is in putting them together and as a hardware unit, and then analyzing the data. That's where you spend a lot of time. Okay.
So next question from W. Nasser. Why is assigning ID important? If an object has moved away from the track of the measurement vehicle, the object may not be some interest.
Okay. So the question is why object tracking is important, right? Okay. So I agree with him. If the object is not within the frame, it's not important. But keep in mind that we are talking about 1/20th of a second. The chances that an object will disappear from the view would be very low. And also, if you have only one object, let's say you're driving in a rural area where you don't have too many vehicles, you only have one vehicle, then tracking may not be useful. But when you're driving on a like urban street, there'll be, I know, hundreds of vehicles, or maybe within the vicinity of the vehicle, there'll be tens of vehicles, like 20 vehicles, 30 vehicles. That's where the tracking is extremely important, because we don't know what you observed the previous slide or previous time stamp. What is that car in the next time frame? So that's where you have to use the tracking. Otherwise, you don't need tracking. But you need tracking invariably in most of the cases, especially if you're driving on a Indian road. That's what we observed. Okay, Ambiga, next question. Do you have any question?
Next question from A. Srivastava. As we show, there is many deaths in road accident by heavy traffic. So, sir, explain some important types of changes in heavy vehicle which performance their work, but not reason of death and accident.
Okay. Again, that question is not relevant to this presentation, but that's okay. I'll try to answer. See, the thing is, the truck crashes. What I see that there are too many issues. Okay, truck. First of all, as the drivers, regular drivers, we are not really giving truck drivers enough space. And we did some preliminary studies when I was in IIT Kanpur, and we realized that their blind spot is much larger. But as a driver, especially two-wheelers or three-wheelers, because the drivers cannot even see them, even the barely two-wheelers and all, they just overtake them from right and left, and they have a lot of issues. At the same time, you have to keep in mind that these drivers have been driving for like 10 hours, 12 hours continuously without a break. So, and also, if you look at Indian roads, we don't provide any facility for the lorry truck drivers to rest. Most of the time, they will be resting on the side of a highway. But in US or most of the other countries, there are proper truck parking areas where they can freshen up, they can sleep properly, so on. But we don't have that facility. So we need to take it as a serious case study, and we need to really see what they need really. Instead of blaming them, I think most of us are equally culprits at whatever crashes they are getting into, because they don't want to crash anyone, they don't want to kill anyone. Same time, we are not, as other drivers, we are not accommodating them on the street. That's my main take, but has nothing to do with my today's presentation. Okay, Ambika, next question, please.
So, sir, one last questions from Arka Bhattacharya. Lots of questions are there, but due to the lack of time, just we will take only one question. So, from Arka Bhattacharya, among all the simulation models, what are the models which we can use in Indian scenario, which will give close to a realistic result, or we need a new one?
Okay, again, I am, to be honest with you, I am not a simulation person, but what I know is that what kind of models are applied in most of these commercially available simulation software. So when I was in IIT Kanpur, even we wrote a proposal to develop one traffic simulation software for Indian scenario. The reason is, as I told you, any existing one, like VSIM is very popular, CoreSIM is important, and Transmodeler, there are so many simulation software available. But all of them are developed in US or European countries. They don't really, care about Indian market. They just want money. And I cannot blame them. First of all, we don't have any reliable data to develop models on. So unless we take our own step in developing something, no one is interested. But if one of us develop a software, it will have huge application, because it's not just for India, for Southeast Asia, entire Asia, or most of the African countries, so on and so forth. But so what I'm saying is, none of them, unfortunately, I'm not confident. I wouldn't use it. Of course, most of the agencies will require you to use this kind of simulation software like VSIM or CoreSIM, those kind of stuff. I'm not confident, because all VSIM does is it will show you, okay, we can simulate auto rickshaw. Of course, on visually, you can see that it's about Instead of a car, you're putting an image of an auto rickshaw. That's it. But its behavior is exactly that of a vehicle. At the same time, more importantly, there is no lateral interaction. Indian traffic, to me, that's the major difference. We have lateral interaction because we don't really care about lane discipline. We don't have lane discipline. We'll just drive wherever we find space. So that's something. So unfortunately, to come to that point, we don't have a software. So I won't use any of them for my own personal use, or so I won't be comfortable with any of the simulation software people develop. So we need to develop something which would be useful for low and middle income countries with poor lane discipline. Okay. Yeah, Ambika. So yeah. So and
Okay, sir. Thank you, sir. Lots of questions are there in the chat box. So due to the limitation in the time, we cannot take all the questions. So I request the participants kindly keep in touch with sir through mail. He can answer all the questions.
Yeah, please email me.
So thank you very much, sir, for your time.
You're welcome. So
Okay, sir. Okay, sir.
Thank you.
Thank you, sir. Good night, sir. So this is a huge response from the participants for the first session. Good interaction is there. Lots of questions are there. So moving to our second dignitary for today's webinar session, which will be delivered by Dr. M. A. Reddy. So Dr. M. A. Reddy is a professor at IIT Kharagpur. He has 26 years of academics and research experience. And Dr. Reddy has published he published nearly 65 technical papers, international, national journals, and conferences. And he has carried out sponsored research worth 350 lakh, apart from the several consultancy projects in pavement engineering. He is indeed a life member of IRC. He contributed to the revisions of Indian Road Congress specifications such as IRC 37, which is used for design of flexible pavement, and as well as for IRC 58, that is for the design of rigid pavement, and also for the formulation of IRC specification, that is IRC 115, flexible pavement overlay design methodology by using falling weight deflectometer techniques. So I just welcome on the behalf of organizing committee, Professor M. A. Reddy, to share his presentation with us. Okay, sir, you can share now.
Can I, good morning. Can I share my presentation
Yes,
from
yes,
my
yes, sir.
laptop?
You can share now.
Yeah, Professor Reddy, good morning. You are audible.
Yeah. I'm just checking where is that. Can you tell me the icon where I can?
So from the right corner, present now, sir, option is there.
Present now, yeah.
Yes, then from there you just.
You are in that, which one I should select? Window?
Yeah, then your entire screen.
And
Yes, sir.
You able to see my screen? No?
You shared your, just you can open your presentation also. Yes, it is opening, sir. Yeah, now it is. Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Fine.
Yes, sir. Now make it full screen, sir.
Yeah, is it okay?
Click hide.
Yeah.
Click hide, sir. Then one link is there. Yes. Hide. Yes, sir. Now it is okay, sir. Yes, sir.
Is it okay? Okay. Start.
Yes, sir. You may continue, please.
Yeah.
The floor is yours.
Good morning. Good morning, all. At the outset, I would like to thank Mr. Teacher for inviting me to deliver a talk on structural evaluation of payments, applications, challenges, and opportunities. So, as all of you know that payment evaluation, this talk, of course, this particular subject or this particular topic relates to the payment evaluation, where uh, we normally uh, look for both functional aspects of a payment as well as structural aspects. Functional aspects, all of you know that this is about the surface or the top characteristics or the parameters of any payment. So, like say we call it as a trading force. Usually, a vehicle like a rider, like a vehicle user, generally takes this as a priority because he always expect the payment to be or road infrastructure to be provided uh, good riding quality, okay, comfort, of course, safety. But on the other side, you also have another important aspect about the load carrying capability of the structure that you have made, or load transferring characteristics or parameters. So these are also equally important. Of course, some are interlinked also, this functional and structural, but uh, both are important. So usually, even the payment design philosophy, you see, payments should not pay both structurally and functionally. So today's talk, I'll restrict myself to only to the structural part. Uh, Normally, what we call it as a general term is called structural health monitoring. So this structural health monitoring is not a new phenomenon. If you see any civil engineering structure, whether it's a building or any historical monument, bridges or steel structures, even roads today, talk about the quality of concrete that is being poured, okay, uh, or any other environmental related stuff that we are talking about. So we always want to monitor, okay, the quality or its performance, okay, functional as well as structural performance. Okay, this is of course is not a new which we are doing, but only thing is the assessment. Okay, there is a shift uh, from even today. Of course, we are using the visual based like assessing the quality or quantity or quality of the structure, it is the payment. And of course, visual, of course, even today is useful, undoubtedly. But all visual, sometimes we may not be able to see some of the damages that are causing, which are not visible to your naked eye. Thereby, mechanical and sensor-based equipments uh, taken a big role in the recent times. So presently, what we are seeing is integration of the hardware and software. That means embedding a sensors into the system. They will collect some data, and the data that has been collected, we analyze. We have some prediction models, or we ourselves will predict and develop some models. Then finally, we take some kind of decisions. Okay, so this is what, in general, it happens in the monitoring, like either structural monitoring or even functional monitoring. So coming to the payment, so I'll restrict myself to the payments. Today's subject is only payments. So what is the need of this payment evaluation? So already I told you that this is very, very important from either from designer point of view or even from the user point of view. So thereby, the infrastructure, the road infrastructure that what we have created today, all of you know that this is going to deteriorate. Of course, rate of deterioration depends on many factors. So we need to assess the kind of functional and structural condition of the payments periodically. So when it comes to India, you know that the recent times for the last, for the last 2 decades, several, of course, you can see that the huge road construction program, whether new roads or upgradation of the several national highways and state highways are taking place. So, and from user, because now we have made most of uh, the, the roads into toll based. So usually riders will expect good riding quality. Of course, they also expect good speeds and also safety. And thereby, we need to upkeep and maintain the road infrastructure that what we have created to the satisfactory levels of the road users. And also, it's very equally important that this, of course, a built-in, like while you are doing this kind of thing, so you'll also be rehabilitating the payments. So for rehabilitation of the payments, what kind of rehabilitation that is required? Definitely we require a evaluation. So thereby it's very important. It is picking up now India because a lot of infrastructure that we are creating, and now this infrastructure is deteriorating also. Of course, likely to deteriorate definitely. So this will continue. So thereby we need to continuously monitor the both the structural and functional aspects of it. So if you see one of the the kind of importance that is being given in recent times, if you see the National Highway Authority of India when they ask for some kind of request or proposal for rehabilitation of existing national highway, so they can see that there are some kind of parameters which this proposal okay talks about. Like for example, you can see surface defect detection, roughness measurement, payment strength measurement by using FWD, bridge inspection, road sign, etc. Means that these first two, I'm talking about this like surface defect detection, roughness measurement, payment strength. So these two relates to the functional and structural evaluation of a payment. So you can see that what kind of instruments that they are recommending also you can see in this slide that for the network that the defects and roughness. So they want a network server vehicle and for strength of the payment, they say equipment called falling weight deflectometer. So once in once in a year you need to do that. Whereas the roughness you can say as per this request or proposal it is twice in a year. So means that this is now become a part of the rehabilitation programs. So all the national highways, so you will be doing this so that the condition of these payments, both structurally and functionally, you can assess, and based on the conditions, you can always think of some kind of a design. So this is what. So if you see in a nutshell, the functional performance means the ability of the payments to provide comfortable, safe, and economical riding service. And of course, a lot of parameters available to measure them, like we can measure by present serviceability index, and there are some rating also is there. We can measure roughness by different and speed resistance, etc. Similarly, when it comes to structural performance, it relates to the structural soundness or load carrying ability of the payment. So you can measure by structural number. That is one way of designating the structural soundness of the payment, or by any response of the payment for load application. The response can be a strain or deflection, whatever. Now, moving on to the introduction part to this, of course, in addition to that, as I said, of course, it's a fact that all the payment deteriorate with time. Of course, rate of deterioration depends on initial construction, how what quality has been gone in, then traffic, climatic conditions, etc. Of course, if condition is not good and traffic is very high, what is being designed, and the climate is also like okay, could not predict or could not able to select proper materials. Of course, the duration will be very fast. So instead of payment deflating like going excessive distances after 2 years, but it starts showing distances within few months. So then how to evaluate this? So structural health monitoring, as I said, it's not a new. Started way back from 1950. Okay, when the Vasho road test, Astro road test were constructed and evaluated. From that time onwards, this particular area of subject also has developed a lot. So as I said, it relates to the load carrying ability of the payment, and how it is done. It is measured in terms of the response of the payment to the applied load. That means you apply a load to a payment, and whatever response that you can able to measure easily. So, and of course, not only easily, but also should have some kind of a correlation with the payment performance. So if you can capture those parameters and analyze them, then you'll have some kind of an idea about its structural condition. So why we are doing this? So broadly, I can say that, as I said, that to know the structural soundness, structural capability, and once I know the structural capability, I can estimate whether this payment can take up further kind of a traffic load. That's called remaining life. And if the remaining life is not what we wanted, what is design life, then we always go for some kind of a rehabilitation. So rehabilitation, it is structural, it can be a structural rehabilitation. So the what we normally do in this is, of course, some of you listeners would have already gone through this kind of presentation, but of course, any questions that arises from this presentation, you can always ask. Okay. So the structural evaluation, the general approach is we apply a specific load to the payment in a specified manner, and then measure the response. The response can be a stress, strain, and deflection for applied load. Okay. So you know when the load is applied, so there are stresses which are induced, resulting strains and deflections. Okay, any influence. So as I said that out of this, which one to measure? So the measurement should be in such a way that it should be easy to measure. Secondly, not only easy, but also should have some kind of a correlation with the payment performance. So thereby, it has been identified that the rebound surface deflection, okay, rebound surface deflection is most common method of measuring the, is the most commonly uh, measured parameter for applied load. Okay, so what we do is once we have this data, the load and deflection data, we can of course based on some selecting some kind of performance criteria, which I'll explain later, you can always assess the condition of the payment. So for a flexible payments, okay, this structural evaluation will give you some kind of idea about structural condition of the payments, and basically the important parameter is called elastic modulus or in-service payment layer modulus of individual layers, including subgrade. Then thereby the overlay design can be assessed. Also, not only for that, you can also doing even construction. You can also use this tool. The structural evaluation can be used for quality control. So, of course, unfortunately, we don't have this kind of a thing. But in some of the countries, when each layer is being constructed, so using this kind of structural evaluation, they also assess the whether the required quality has been achieved. Okay, can also be monitored. When it comes to rigid payments like concrete payments, it's even if there is a more elaborate applications are there. One is, as usual, you can find out the elastic modulus, and also one of the other input parameters for the concrete payment design or rigid payment design is modulus of subgrade reaction or K value of the entire structure. Okay, on which the concrete layer will be placed. And the other important thing is the load transfer efficiency, LTE, load transfer efficiency across the joints. And also you can identify any loss of support at subject corners. You can also think of set of thermal curling, okay, the frozen support conditions if they are there. So this will give effect of those environmental parameters on the response of a concrete payment. Seasonal load restrictions for certain low volume roads, you can also do that. And evaluation of the, of course, payments which are prepared. Like you have done some kind of a rehabilitation, and maybe for concrete roads like stitching, stapling, you have done, and now you wanted to assess whether whatever rehabilitation that you have undergone, I mean, you have undertaken, is useful. Okay, is it giving some kind of improved results? That also you can. So coming to the how this method has been evolved. Okay, as I said that way back from 1950 to 2020 today, and we are today. So there are basically four kind of because I told you this is a load based. Like you apply a load, then find out the response. Response in terms of the surface deflection. So it started from static load based applications. Today we have a dynamic load. Okay, from static load, the journey started with static load, where we have instruments called plate load test. Of course, even still we are using here and there. Benjamin beam, which is very popular, curvature meter. Okay, then all these, and then of course people started. This Bentelman beam became very popular, and there are some kind of limitations. So people started modifying this, so thereby automated deflection beam like Black 6 spectrograph, California traveling deflectometer, some kind of devices modifying to this Bentelman beam also started. Then they move to the other equipment, vibratory roller, because the fact is why this has happened was people are trying to, that means researchers are trying to simulate to the field condition. So what is the field condition? A truck is moving, maybe carrying a load of, let's say, standard load of 80 kilonewtons, which is a dual wheel, and it travels at say 60 or 80 kilometers per hour. So whatever deflections, rebound deflections are tilting due to this traffic truck movement. So that should be captured. But if you see the static load, the load is applied statically, which is far away from the reality. So thereby, development took place. Next, they moved to vibratory rollers, vibratory load based, where dyno feed, road raters, okay, have come up. Then, of course, this is also not realistic. Then impulse based load man, falling weight deflectometer, heavy weight deflectometers, all these kind of things have come, which are impulse based. But today, from 2010, of course, that in the last couple of decades, dynamic based loading, like rolling wheel deflectometers or traffic speed deflectometers, are also started coming in, where they simulate to the greatest extent to the field condition. So briefly, this is the started Beckelman to the dyno fleet, road rater, FWD. Then we have a rolling deflector. So coming to these applications of this, so in India, we see that a guideline was formulated that's called Benjamin beam deflection, that is overlay designed by that is called strengthening of existing flexible payment using BBD technique. So they have taken the guideline, mostly the data from Dasher road test, where AC Benkelman formulated kind of a procedure, and this was adopted and this was used by different countries all worldwide. Okay, even India also, we have formulated guideline IRC 81 1981, where of course not much research has been not based on any much studies, just some tentative guidelines were drafted. And later on, and the government of India, that is Ministry of Road Transport and Highways, has sponsored a research scheme called R6, correct, R6, and a lot of academic institutions and research institutions, academic and research institutions, have participated in collecting a lot of data. That time, payments, National Highways also had got VM, wetness mechanism, as the structural layer. So a lot of data was collected, And based on this, okay, a guideline was formulated. So that is called first revision, and that is called guideline for strengthening of existing flexible load payment using DBT. And it was also said that in this guideline that he said, see, all IRC are the guidelines; they are not codes. So it's been clearly said that use these guidelines. A lot of data, what has been collected through this, and the performance, okay, need to be again captured, stored at some place, and then those should be analyzed. The data should be analyzed to revise the guidelines. But unfortunately, no further revision took place for this IRC 81. Though there are, because see, all these guidelines were formulated based on some kind of a limited study. But unfortunately, though most of the, our agencies use till recently only this method, but there is no data compilation and then no analysis has been made. Thereby, no revision also took place. So it is being a lot of usage was there across the country. That is a one. So what is in it actually? I think most of you may be knowing. Of course, for the for the people who are like new to this. So it is like you apply a load statically to a truck. I'll show you. Then you remove the load. So when a load is applied, it undergoes a section here. So you measure, have some kind of a, of course, here we use a dial gauge to measure this rebound deflection. Like once I remove this load from here, I am showing an arrow. If I remove how much the deflection that has undergone will rebound. So rebound deflection is being measured and recorded actually. So this is a method called CGRA method called Canadian Good Dose Association. Same thing has been adopted in IRC 81. So rebound deflection is measured as load being removed from the point. So this is a long beam of 3.66 meters. So you have a simple device, mechanical device. You have a dial gauge here, and this will be kept in between two. Sides of the dual. So this is a photograph which you can see. We'll be placing this, and of course you require a loaded truck with the standard loading conditions and air pressure. And of course, the laborious. Of course, the advantage being, there are several demerits, but advantage being with simple instrument, rugged instruments, you can collect data. So this is what. Of course, there are several. Of course, based on this, a overlay design has been proposed. Suppose if you know the characteristic deflection, so that from the deflection you measure the characteristic deflection. Then if you know the traffic, design traffic, you can always get this is what design traffic up to 100 MSA, and if you know the characteristic deflection, you can measure what is the overlay that is required, okay, in terms of BM. That is thickness mechanism, because this, as I said, that the data that was obtained from thickness mechanism payments time back in 1990s that time. So those were there. So you have conversion factors where BM can be equivalent of DBM and BC can be done. So this is what the procedure which was used. So there are several demerits of this. The first one, as I told you, that load is not being applied statically. Of course, even that, even if you consider, okay, it's fine. But one single deflection cannot give the structural, what you call the condition of the entire payment, or if you want to talk about individual layers, the contribution of individual layers, you cannot assess that. For example, this figure shows that two payments, A and B, have got same maximum rebound deflection, but you can see the curve, you can see the profile of this the deflection bound, they're entirely different. So thereby, the properties are the different layers will be different. But if you just blindly measure only one deflection, you cannot do that. Then to overcome this, people started measuring the entire deflection bowl also, like putting several what you call the dial gauges, and they measured. But the first demerit remains the same. That is, load is applied. Load is not applied statically in the system. So thereby, people have migrated to the other ways of measuring the device, that's called vibratory based. So here, a lightweight device which makes some kind of a vibration, gives a vibration to the payment, so these vibrations, of course, are being picked up by sensors, okay, and there are velocity transducers like geophones are kept. So you'll be measuring the load as well as the response of this vibratory kind of a load that is being given to the payment. So both load as well as the peak-to-peak dynamic force as well as the response of this, that means the deflections are being measured. So though it is okay, but I mean, even some advancement in terms of load applying, but load is not fully applied through vibratory. It's like a moving. Okay. So thereby, these methods did not last for several years. So then people also worked on something like structural analysis surface waves, like surface wave methods. So this is like just dropping a hammer, okay, and trying to measure the surface waves. Okay, and these surface waves, when you capture, so you will be dropping a hammer like at the payment, just impact source, small thing. So then there are two receivers, and with these receivers, you can receive the surface waves that are being generated, and then through this, you can also determine the elastic modulus and thickness of the. But again, the load that is being induced and the receivers that you have, so only surface wave, so it cannot give the entire structural properties of all the layers which are there. So payment is either 4 layers or minimum 3 layers. It can even go 5 layers also. So it cannot really give that kind of a information that is required. So even these methods did not last for, of course, though people are using now and then, but may not be useful for when you have a multi-layer structure. Then comes impulse-based, where this is what the kind of things that are happening today. Impulse, of course, dynamic, of course, I have included impulse and dynamic here both. So impulse load, first three are lightweight deflectometer, so like LWD. LWD, so like what we call load band. This is mostly used for single layer. Like we have a subgrade, you want to assess the property of this subgrade, we can do that. Again, of course, then when you have some thin asphalt layer over that means very thin, not thick, thin asphalt layer, that means 2 layer, but for structural point of view, you can consider the single layer. So for that also, this is useful. But when it comes to national highways in India, where the layers are made with different materials, 3 to 4 or 5 layers, so load man will not work if you have more layers. So for multiple layers, so equipment called FWD, falling wave deflectometer. So from 1980 onwards, okay, a lot of work has gone in around the world. So thereby, this equipment has become very, very popular in the entire world. Even today, most of the companies, or not most, almost all agencies, government agencies are private. So they are using the FWD based, okay, that means impulse based evaluation for finding out the structural, or finding out the structure, or for carrying out the structural evaluation of the payments. Of course, the higher version is like for airport payment, the same heavyweight deflectometer. This is for airport payment because the load that used to be dropped onto the runway or the airport infrastructure is different. So even loading freight, etc. is different. So even these two are even today being used. The fourth one, the development is travel speed deflectometer. That is under that comes under a dynamic kind of a loading, which is on an experimental basis. Of course, US and European countries are using, even Australia also. They are using the next level of the deflectometers called travel speed deflectometers, where when you want to talk about network survey, like if you want to evaluate the thousands of kilometers of highways, okay, your FW also cannot do that. Okay, thereby, and also, of course, the achieving the field simulation, that is vehicle is traveling, then you capture the rebound deflection data, so that will have a even better understanding of the materials, etc. So they like this has developed. So as the impulse based equipment is very popular around the world, including India in the recent times. So I'll be just discussing about a little bit in depth about this FWD based. So as I said that it is impulse based. So you apply impulse load to the payment and measure the deflection bowl that is being. That's what you are going to do that. So more surface deflections are, suppose if you have more surface deflections, more information is available about the payment. Suppose if you have one or two only, you will not be able to talk about the structural condition of all the layers. So using this surface deflections at suitable locations, okay, so you have to measure the entire deflection bowl. So you'll be placing them at pre-selected distances from the loading plate. Then what you can do is you can do the interpretation about the different materials, that is different materials that are being used in the layers. So as I again to summarize, so structural evaluation of in-service payment is usually carried out to assess the, as I already told, that structural soundness, estimation of remaining life, requirement of overlay, estimation of their remaining life, and overlay requirement. Just repeated this, sorry. So coming to the equipment, like I'll just go to the details about the equipment. So this is like a impulse base. You have a load, falling mass, it falls on a rubber like some kind of a rubber, of course, rubber mass here. There are springs which is now represents gives some kind of damping. Okay, you drop a load, and then this will result into a deflection. Of course, why this damping is required? Because you need to apply the load simulating to the vehicles which are moving at 60 kilometers per hour. Let's say. So you'll be adjusting the time of application of load by changing the rubber pad stiffness, etc. Of course, this is what we have to do in the beginning. So rubber pads, the stiffness, number of rubber pads, all these things you have to, usually when the supplier gives you, I mean, a vendor gives you, he'll do all these things and give it to you. But as you use them, so they become hard, the stiffness increases, thereby the load pulse that are being generated will decrease. So you need to calibrate even the load springs, okay, on a regular basis. Of course, initial few years you may not require, but later on you have to replace these rubber pads. So then you have a sensors. You have seen D0 to D5. There are 6 sensors, which are of course a lot of work has been done on those. So most of the agencies keep them at 300 meter, 300 mm distance. So up to 1500, you'll see 15 or 1200, 1500, 18. Some FWs have 7 sensors. 6 is very common, but 7 also you can use them. So of course, these are the inner parts of some FWs. Of course, I'll show you some of the things. So this is what the principle that is used. So you have a falling mass, then you'll be measuring this rebounded surface deflection. Okay, so if you, of course, if you measure the, I mean, one side, we assume that because of the symmetry, it will have similar kind of thing on the other side as well. So this is a principle. Okay, and we try to give a standard axle load, which is 40 kilonewtons on a 300 mm plate. So you have to, you should not, I mean, because there's no linearity, like load versus deflection may not be linear. Of course, in some range it is linear, but other range it cannot be linear. Thereby, you have to ensure that every time when you try to collect the data, the deflection data, you have to apply load close to 40 kilometers. But it's not possible always to have 40 kilometers. But you can always monitor when you're dropping the load, you can see what is the load that has been given to the payment. So if it is far less, like suppose 30 kilonewton or 50 kilonewton, you have to reduce it. Okay, either reduce the drop of height or increase the drop of height accordingly. Then make sure that you'll be around 40 kilonewtons around. So now, because this is being now there in Indian guidelines, okay, that IRC 115/2014. So what is the Indian experience with FWDs? Okay, so it started with the Central Road Resistance Institute in PRRI way back, long back. Then of course, Military College of Engineering, CME Pune, because of their airport assessment, they used to have this. Today also they have that. Then of course, IIT Kharagpur with Professor B.V. Pandey, who has contributed, of course, immensely for development of this particular equipment from scratch. Okay. So recent times, because the guideline has come up from 2014, of course, from 2015-16 onwards, it's almost like mandatory to use this kind of instrument for structural evaluation. Now, many consultants have procured them for the last 3 to 4 years, and even some of the academic institutions also have this kind of instruments. So, yeah, as I said that this entire work goes to late Professor B.V. Pandey, who has contributed immensely for development of this. So, at Kharagpur, there are 4 models which have been developed way back in 1992. We have a simple model. It does all the same purpose. The only thing, everything is manually operated. Your phones, loading by tripod, so you can lift the load and release the load. Then we have a semi-automated model, 2001. This is from a sponsored research project from MHA, sorry, MOTH. Then 2010, another version, fully automated version, and 2016, most like what you call compact kind of FWD was also, developed. So as I said, that the purpose of this is, in a nutshell, to get the modulus value in service payment laid modulus, load transfer efficiency in case of digit payments, and also modulus of subradiant, K value. A K value is another input that is required for payment for digit of digit payments. So there are a lot of important models available across the world. Okay, Dino Test, Phonics, many companies, and in India also a lot of these important models are available. As I said, this is not a new technology. It started from 1980. A lot of work has gone in. A lot of work has gone around the world. A lot of literature is also available on this. And of course, each instrument, of course, it varies in the, like some instruments have got one plate, some instruments have dual plates that resembles the actual dual wheel thing. And of course, the data, of course, all the instruments collect the deflection data undoubtedly along with load, but how they're going to process this data. Okay, so that has a different kind of concept. Okay, that is, analysis will be different, but of course, load application also slightly different in some models, and analysis is totally different. That I will explain. So this is the FWD. You can see the important components. What I show is the loading plate. Of course, this is a mechanism to use that pulse load and deflection measuring devices here, and all the data is captured here. So you have a battery backup. So everything is a hardware part. Of course, you have a software to collect the data. Of course, processing, of course, you can do in situ, or you can come to the office and you can, whatever data that you collected, you can calculate, of course, analyze this data. So this is a principle I already told you. So what is the major application of this? So as I said that the what you call one guideline has been released that is called IRC 115/2014. So based on the, as I said, that MORTH sponsored research project R81 done by IIT Kharagpur. So guidelines were formulated. So I'm not going to the details, but I'll only just tell the gist of this. Okay. So you'll be measuring the, as I said, that a load is a transient load is applied and the deflections are measured. Okay. So some of the important features of this load plate. Okay, you have a load plate here. Sensors, data system for capturing the load that is being induced and also the deflection that are resultant due to the application of load. Then there are some sensors for air, measuring the air and payment temperature. Of course, there's a power pack. So one of the important feature of this, of course, very important thing is you have to calibrate the measuring devices. Like load cell has to be calibrated, okay, regularly, as well as the sensors also have to be calibrated. So in the different countries, different calibration processes have been developed. In US, there are calibration centers also. So you can take your FWD and get calibrate the instrument. But in India, of course, we don't have. But the only thing is the vendors who are supplying this, of course, not that difficult to calibrate. Calibration process are given. So the calibration that is being suggested here is, of course, the other device is called the geophone. So geophone, where a mass is suspended by means of a mechanical strings, and the mass will remain stationary for a frequency greater than the resonance frequency of a ground. And then this response of the coil or magnet, okay, which is there in the geophone, is directly proportional to ground velocity. So you measure the velocity. So from there you can integrate it and get the what you call the displacement that is occurred because of the application of load. So these two, load as well as these geophones, need to be calibrated. So there is a procedure given in the IRC guidelines also, like we have to do the absolute calibration or relative calibration, and they have also given the how to do that. Okay, we need to have some kind of the calibrated device against which the geophones have to be calibrated. Okay, so so this is a calibration that we have adapted. We have a vibration meter, and where that will give you the the actual. This is already calibrated. So this instrument gives the deflection that is being occurred because of the drop in. I mean, when you drop a load, and you have to place a sensors there, and you capture the sensor data also, and then you can correlate these two and get the calibration constant. Of course, there are different methods. We have this one is a gauge. We have a fixed gauge, which will give you the this is also calibrated gauge. Right? It gives a different when you set, it gives a different vertical deflection. So you'll be calibrating your geophones against this. So we have 3 slots. You can see these 3 slots. If you keep this, you get a fixed deflection of 0.6 mm. Here, if you go, it's maybe 1.2. If you go here, 1.8. Or you can have different slots. Each slot, when you keep this kind of a jig, it gives you the different kind of level of deflections, and your devices have to be calibrated against this. So calibration is important. So right now, this is a calibration procedure that is being given in IRC. But as I said, that different agencies adapt mechanism to calibrate. So next one is in the guidelines, they have given how to capture the data because it's a field instrument, as all of you know that the field, to go to field, you have to identify the section, position the FW over there, and there is a spacing. Of course, guideline gives you that at what interval that the data has to be captured. That depends on the payment condition and how many drops, etc. All this information. So once you collect the data, the other input parameter that is required is you have to also have a payment thickness. Payment layer thickness is very much essential to analyze the data that is captured. So the thicknesses you can get it from either by historical data, if the construction is full records are there, which are correct, you can do that. Otherwise, in India, because the construction, of course, records are not that maintained properly, so you have to excavate some kind of a pits and get that. But also you can use a GPR, ground penetrating data also can be used, from which you can get the thickness of existing payment layers. Okay. Now, of course, the guidelines also talks about, as I said, now at what frequency, at what is the spacing at which the data has to be collected. Then how to make the payments into homogeneous sections. For example, you want to rehabilitate 100 kilometers. This 100 kilometers will be divided into homogeneous sections. How to make homogeneous sections and how to analyze the data. Everything is given in this guideline. So I'll be talking about analysis. So analysis, once I have this rebound surface deflections, I have a thicknesses, and I know how much load I have applied, I know the payment temperature. So with this data, what I do is I'll try to, what I do before, of course, I require additional data to get that rehabilitation. So additional data is the properties of the materials is required. So all these deflections and the thicknesses that are required, of course, in addition to the amount of load that is applied. So I need to I need to estimate the a kind of layer moduli for the payment where I have done this kind of a evaluation. So this analysis is called back calculation. So back calculation of payment layer moduli. So what do you mean by back calculation? Back calculation is nothing but the process of selecting and adjusting the layer moduli, different layer moduli, using any technique. It can be iteration based, data searching, closed form, so that deflections measured using the layer moduli that you have selected, and they should be very close to the measured deflections. So that means every time you generate a set of new moduli and calculate the deflections, and these deflections should be close to the deflections that you have measured. So this is adjustment. It's an iterative process. Okay, iterative process of selecting this. So a lot of back calculation methods are available, regression based, ANN, TA. So Kharagpur also has developed, as I said, that iteration based, data searching, closed form solutions, all there. So we have used, of course, Kharagpur also developed some kind of backend program, which we call it the BACGA, which is also there in the guidelines. So which is nothing but a blend of ANN and DA based, genetic algorithm based. So where what it does is, as I said, that it selects a most appropriate layer moduli for a given deflections and of course other thicknesses, etc. So this is the information that is required. Measure deflection, layer distances, etc., etc., and you'll be measuring the, you'll be getting the layer moduli. So once I have layer moduli, this is a flow chart available, and of course you can see this objective function that is being used. Of course, different back calculation programs uses different objective functions. This is a flow chart. This is a flow chart for general back calculation. This is a flow chart for the TGP back, which is there in IRC 115. So here, of course, the moduli that we have got it, okay, because the testing would have been done in summer, but you want the seasonal effect. So we have given some kind of a corrections for temperature. This is a temperature correction for the moduli that you have back calculated. This is a temperature. This is a seasonal, like moisture, mostly for unbound material, that is for subgrade and subbase. Because if you have done the testing in summer or winter, if you want to know the back calculation moduli in post monsoon, which is the worst condition. So you have some limited studies. This is the things which have been done. So a lot of back calculations are available all over the world. Okay, several back calculations. Mostly in US, each university, most of the universities have developed their own back calculation program, which are available. Some are freely available in internet. You can get them, and some are, of course, have got with your, of course, with them. So all these backend programs, they are different, gives a different results, because numerical routine used to calculate the payment surface deflections is different, and method of searching the new set of layer moduli is different, and some programs uses stress dependency and some do not use it. And what the convergence, like when you say that okay, program should terminate, so convergence criteria are different, the objective functions are different, and the range of moduli that you give is different, and some backend programs do not consider the fact bedrock. For example, if there is a stiff layer, so stiff layer in between two soft layers, so whether it can identify, so it's very difficult. Some backend programs has got bedrock consideration, some do not have. So thereby, it is not just a mere entering the data, okay, into the, like you have a deflections, I just enter, I get some output. It's not like that. So you require a lot of knowledge or information about the different parts. One is, you should know the what are the material properties. Thereby, you can choose a range of moduli. So for range of moduli, you may have to use some regression-based equations how to be used. Though IRC 115 gave some kind of some kind of guidelines, but they may not be adequate. You have to even widen up Poisson ratios. You give something, maybe they may be slightly different. Then non-linearity, effect of temperature, how you are going to consider this, whether you want whether that also need to understand. Then variation layer thicknesses, because you take a peak at 1 kilometer, then within 1 kilometer you assume that everything is uniform. It may not be uniform. Then the payment behavior, like you have to understand that if there is a thin layer and thick layer, okay, you are analyzing. So things are different because the surface modulus is influenced by the deflections which are close to the load applications, whereas the lower layer modulus is influenced by the deflections which are far away from that. Then stabilize the layers. So like a soft layer is stand which will be two stiff layers, or vice versa. Which is very common now. Today we are using CTB, USB, CTSB. Okay, and whether our program should able to, because that is a very stiff layer. Okay, and above that it's not that stiff layer. Okay, if you use a WMM, it may not be that stiffer compared to your CTBSB, etc. CTSB. So whether the stabilized layers, whether you can, whether there are any stabilized layers which are there in the existing payment, that you have to know. And the backend program that you are using, what is the sensitivity of the inputs, and what are the assumptions that you are made it, okay, and what are the errors that you are going to because of the instrumentation. All these things you should have a information, a careful observation. Then only you can use the backcalculation program, and where it will try to give you a most appropriate layer moduli for the data that is given. And even the paving mixes that are used, so maybe we're different. You assume that everything is same, but things may be different there in the field. So the field information, like a lot of information, is also required when before you analyze the payments. Okay. So of course, once I have that layer moduli, I have a traffic, design traffic, and what I do is I back calculate. Of course, I have a traffic, I have a back calculation layer moduli from the back calculation software that I use. So with these two information, so there is a overlay design procedure. So anyway, I'm not going to the details of it. So you'll be analyzing the payment, basically a three-layer structure or three-layer structure. Then you'll be finding out the critical strains at two locations, as you normally do in for design of a new payment. And these critical strains will be used in the performance equation. There are performance equations here. Okay. You try to find out what is the life in rutting and what is the life in fatigue. And if these lives are less than the design life, then what you do is you put another layer, it's called overlay. And for overlay, you select a thickness and the material like the E value, because it's a new layer. Then once I put a new layer, these stains are going to reduce, and you ensure that the life in fatigue and rutting will be slightly higher than the design life. That is what the the overlay design process that comes. So this is being clearly given in the. Now, what are the issues here? What are the issues is, again, now in the recent times, a lot of people are collecting a lot of data, and they are trying to use this data for interpretation. So thereby a lot of doubts are coming up. So one of the doubts is, what is the selection of range of modulus? Range of modulus that is given was, well, as an example, we have given, of course, in the guideline, because now if I test the payment, sometimes I may get modulus value even much higher than 3000, maybe 7000, it may be correct. So you have to select a proper range of modulus. As I said, that you may have to use some regression equations, which are not incorporated in the guidelines. Of course, such kind of, and you have to examine the condition of the materials also, by maybe taking force, etc., and see and give a most appropriate range of modulus. So that is required. And the seasonal variation, the models which I have shown you, that means correction for temperature, correction for seasonal variation like summer, winter, they're from very limited data. Very limited data, very limited data. So now is the time to revise those, what you call, the models which have been given there. And the other important thing is this backcalculation program which we have developed is only for 3 layers. So nowadays, as I said, that is a 4-layer and 5-layer. So what we are doing is we are combining 2 layers and trying to give a same modulus for all the layers, which may not be correct. And in the recent time, we have a stabilized layers which have come up, CTGSB, CTSB. So that is called bedrock kind of a thing. So our program, whatever that backcalculation program available, which is not capable of identifying a bedrock. Okay. And the other question is whether can we correlate with other devices like this. For example, FWD and BBD. We can do, but it will not be much useful, because of course to some extent you can get some kind of a correlation, but as I said, that you are using single deflection there, you have multiple deflections there, so it may not be good. And even the FWDs have come up very cheaply in the recent times. I don't think that there's a need for correlating BBD with FWD, because FWD itself you can start using and get the experience, and then that is definitely a rational way of evaluating the payment than BBD. But somebody can try even correlating with this. Okay. So other applications I'll just quickly go through because I'm running out of time. The other applications are, as I said, that you can also find out the load transfer efficiency. This is a concrete road which we have constructed on an NH33, the short panels. Of course, same thing can be used for usual jointed cement concrete payments, where the load transfer efficiency, LTE, this is a joint. So I can see what the load transfer efficiency, how the load transfer efficiency is going to diminish. So I can find out using the FWD. So this is our the short panel concrete payments which you have laid on NH33, and where there's no double bars here, so only aggregate interlocking is there, and except at the construction joint. So we are trying to find out seasonally that how the aggregate interlocking is contributing towards load transfer efficiency through FWD. So again, we have done, this can also use now. See payments, concrete payments especially during midday and midnight, so they may not remain flat, because of the curling effect. So that is the actual condition. So during that time, if I apply a load, how the load and curling affects the behavior of the concrete pavement, if I want to study, so I can use this FWD, because when the pavement is lifted up, so I can do this. Of course, this is comparison. Similarly, in conventional concrete pavement, I can do the load transfer efficiency of a double bar system, because already I have a double bar. I want to know that, so whether double bars are giving 80% or 70%, 90% load transfer efficiency, I can do that. Okay. Similarly, modulus of separate reaction, you can find out. So all these things, even the gaps which are underneath the foundation, whether foundation is being lost. So all these things can be done with this. So this is, of course, we are yet to, because we have just started this, but in US and other places, they have already used this for the last almost 4 decades. So now they have gone for other kind of devices, like, because FWD organ, it will stop, apply a load, then move forward. So lane closure has to be there, and it is slow, especially when you are talking about network level application. And simulation to the field condition is not, because it's not that simulating. I mean, if you talk about moving vehicle, so thereby people started developing this rolling weight deflectometers where it moves, and you have a laser beam. You can see, you can laser beam the collects the rebound deflection because of the load application. Of course, this is under experimental, and some people are using this. And travel speed, you have a, of course, now the equipment has come where this will move with almost like 80 kilometers per hour. And in addition to the deflections, you can also measure the texture. You can also measure the roughness. You can also measure the the rutting, all the parameters. So integrating functional and structural aspects, and when you move along. So that is also has come up. A lot of work has of course yet to be conducted on, because this is, of course, people have started using, and of course it has not come replacement to FWD. Okay. So that's all my presentation. So of course I have just exceeded my time. Okay. Of course I'm. Thank you, and if you have any questions, please. Thank you.
Hello.
Hello.
Yes, sir. Thank you very much, sir, for your outstanding speech. So lots of questions are there in the chat box. Shall I read out?
Okay.
Okay.
No problem.
Yes, sir. One question from Anna. So how structural number is depends upon the relatively of the pavement structure?
Structural number, see, ASTO does the structural number. Okay. That's one way of converting finding out the structural cable of the entire pavement into structural number. That is ASTO procedure. Of course, naturally, see, if the layers are having definitely in a good condition, definitely the structural number also more. That coefficients also will be more. So thereby you get the higher structural number.
So the next question from Purushottam Kumar. What will be the property of deflection surface in case of rigid and flexible pavement?
See, rigid pavement usually, as you know, that because the why they call rigid is because the deflections are relatively less. Actually, it's not, nothing is rigid actually, but the deflections are relatively less. So in concrete pavement, definitely you get a, of course, less deflections compared to deflections.
Another question from TV Reddy. Minimum how much load is applied for structural evaluation?
So it's a 40 kilonewtons because the standard loading condition is 40 kilonewtons. That's all over the world because we convert everything into standard load. Like if you have dual wheel, so we convert them into 40 kilonewtons. Like 80 kilonewton is the total load on 4 tires. So we take 2 tires, so 40 kilonewton is the load. That is 4 tons.
There's another question from Arvind Kumar. What is the length of instrumented rigid pavement stretch in India for structural health monitoring?
What is the minimum length?
Yes, length, rigid pavement stretch in
No,
India.
that is actually, see, even if it's 1 kilometer also there issue, somebody that, based on the importance of a road, like take a national highway, even if it's 1 kilometer also, you have to do the structural evaluation and get the overlay required. So there is no such kind of minimum length, but of course, you will not be doing for 100 meters or something like that. So 1 kilometer, half kilometer, anything more than half kilometer, yeah, you have to do the structure. Of course, the number of points, because in IRC guideline also based on some statistics, so they have given the sample size, that's which spacing you have to take. So spacing varies from 60 meters to 500 meters. So it depends on the condition of the payment and what type of payment it is. National highway, state highway, you do that, but normally for MDR and all, not.
So another question from Anna. Sir, can we combine all these equipments like Benkelman beam, follicle deflectometer, road ratter, etc. into one equipment? May
No,
it be more efficient?
No. See, Benkelman is entirely different. Now we have to think that is outdated actually. The reason is I already told you a lot of demerits, okay, because that cannot be integrated. See, the last instrument which I showed you, TSD, where many other features, both structural and functional aspects have been integrated. So you cannot integrate Benkelman with FWD. They are entirely different.
So another question from Lakshmi Narayan R. So in case of Benkelman beam, is there any specific reason for fixing distance at 2.7 meter, 9 meter for intermediate and final?
Yes. There is a reason because it's in the Vasho road test. So they conducted that the influence of this deflection beam, the deflection beam legs should be basically should be away from the deflection bowl. So they found that at 2.7 meters, yes, the deflection bowl will not fall under the front legs of the thing. But however, at 9 meters, yes, the entire influence of this has been influence of load application is totally diminishes. So, however, in some cases, of course, they have given the derivation also for this, so how that 2.7 came into picture. If you see in the ASTO design, the ASTO that reports, you will get that. So usually the 2.7 meters is a place where the legs of the beam will be away from the deflection.
So lots of questions are there. So the one last question I can pick that from the Aditya Ghosh, whether light falling weight deflectometer is feasible in measuring surface deflection modulus when compared to the other deflection measuring devices mentioned by you for Indian pavement conditions.
You are talking about loadman, lightweight deflectometer?
Lightweight deflectometer.
Yeah, lightweight deflectometer, the application of lightweight deflectometer, if you have one layer, then you can use it. So one layer, or if you have two layers, but second layer should be very thin, like now, for example, 20 mm or something like that, asphaltic material. But for that, it is okay. But when you have more layers, single deflection, you will not be able to get information about the properties of two layers and three layers. For one layer, especially for subgrade, that's why if you see in most of the countries, when the subgrade is being constructed, they use this loadman to check the quality. So only for one layer or one layer with two layers with thin the surface, loadman can be used. Otherwise, no. Because load application is very, very less. And then even if you put more sensors also, you will not get the deflection for that small amount of light. But one layer, yes, you can use it.
So one interesting question from Ashish Dolari. So dear sir, where exactly the loading plate of FWD has to be positioned on white topping to determine the LDE in white top payments.
Which one? White topping?
White topping.
Okay.
That where exactly the loading plate of
No, see, white
has to be
topping,
positioned.
see, what is the purpose of white topping? For example, if you want to know the, for example, in the design purpose, say, so design, there are critical locations. Okay. You have to take maybe at corner or depends on design principle where you want. But if you want, see, for example, just to know the layer properties, etc., you have to take at the center. But if you want to know the load transfer efficiency, let us say, it has to be close to the joint, close to the joint. And if you want to know the, like if you are like, if your white topping is critical, like stress are critical at the corner, you have to apply load at corner. So like based on the utility, what you wanted to know, whether it's just UV value or load transfer efficiency or for design. So depends on that, you have to position the.
Okay, so lots of questions are there in the chat box. So
No problem. Let them
yes.
send it or let them definitely will reply.
Okay, sir. So one question from from Dipans Yadav. Sir, can the modulus values obtained from AWD, either composite or back calculated layer moduli, by directly used as elastic modulus of pavement layer?
No. See, this would not be like, for example, whenever I am, see, this is like I use this FWD back calculated moduli, and these have to be used in the procedure that for which the like input parameters usually take. For example, I cannot use this back calculated moduli in some other program where the elastic modulus is to be determined from laboratory. So I should use this backend moduli. For example, in this case, I have to use it in the overlay design only. So I cannot use this moduli in my new payment construction. I cannot use it. So that is because both are moduli only, but the moduli there is for a newly constructed payment, but here moduli is in service. So I cannot interchange them. That is what, see, whatever the procedure says, use the moduli from laboratory means you have to use it moduli laboratory from this particular procedure means you have to use only that particular procedure. But I cannot substitute laboratory moduli with my field model.
So another question is from the same participant that sir, when can I expect some guidelines regarding use of NWDU for structural evaluation of basis or the sub basis or the thin asphalt payment from IRC or MRT?
So already it is there now. See, this FWD, you can calculate all the layer moduli. Existing guidelines also you can model, you can find out the layer moduli of all the layers. Subgrade, subbase, everything. But only thing is, 3-layer only it is there now. If I want, like, I have to make a 4-layer, 5-layer, analysis has to be made different. We are working on that, and soon we may replace existing back calculation with 4 layers and 5 layers. 4 layers, hopefully. But already it is there. You can estimate the back calculated model of subgrade, subbase from the existing.
So another question from Samadhi Dev. That are these methods give the exact value or relative values on pavement health?
Huh? Which one?
Are these methods give the exact value
No.
or
See,
relative
that's why I
values
told you,
on pavement health?
if you use 2 back calculation software, big calculation, they'll give different knowledge. Because I told you there are reasons. Because as I already told you, because some takes a stress dependency for some of the layers. Some methods will have different convergence criteria. So they will not give a unique value, like not unique value. They will be different. So a lot of papers are available. Why they are unique? I told you some of the reasons. They will not be unique. So they'll be different. That's why you have to be very specific that when you are even trying to say the methodology, so you have to use this software, that software. Of course, they'll be close, but may not be exact value. Because convergence criteria are different, errors that we have selected are different. See, every layer you consider linear, but some programs consider non-linear. So thereby, modulus values that you get are different.
Okay, thank you, sir. Yeah, lots of interesting questions are here. Participants are actively participate. and they reacted with the experts. So this is a nice presentation here from you actually. So on the behalf of all the members, I want to thank you for your insightful presentation. Thank you.
Yeah, thank you very much. Thank you.
Now moving towards our third dignitary of today's session, Dr. S.D. Velmurugan, sir.
Ask him to turn on the
Murugan sir is left, huh?
He's not there.
Okay.
You call him.
Call Murugan sir.
Yes, sir.
Oh,
He is here.
he came back.
He's back. He's back.
So just a brief biography of Sir Velmurugan, sir. Dr. S. Velmurugan is presently working as a chief scientist at CSIR, Central Road Research Institute, New Delhi. So he was instrumental in the formulation and revision of 15 IRC publications during the last 12 years. He has served in the capacity of project leader coordinator in the World Bank sponsored projects as well as National Highway Authority of India and state public works departments, sponsored projects for the conduct of various stages of road safety audits covering more than 9,000 kilometers. In 2018, he has completed a CSIR sponsored project titles Indian Highway Capacity Manual, Indo HCM, sponsored by the Council of Scientific and Industrial Research by assuming the role of champion. He has published more than 150 technical papers in international and national journals. So we are here to, from you, sir, your expert knowledge in this area of the road safety audits. So, sir, over to you, sir.
Okay. So I should share the window or entire screen?
Yeah, I will stop
You
the
unshare, no?
presentation.
Unshare it.
Yes, yes, yes. Yes, I stopped sharing.
Yeah.
Yes.
Go to a window.
Now, in the right corner, present now.
Yeah, I'm just
Yes.
seeing that.
Yes, sir. From there, that entire screen.
Yeah. You got the screen now? Is it,
Yes, sir,
has
it is coming.
come?
Yes, 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 sir. It is visible.
Yeah. Thank you, Dr. Ambika, and the entire team of coordinators of MTTS 2020 for inviting me to make a presentation on this topic of an overview of road safety and road safety audit in India. I would like to do a case study presentation on the evaluation of road safety audit implementation. So I would like to first of all thank the entire MTTS organizing team, which is NIT Silchar, which is being organized under this TQ3 funding, I suppose. So I'll be keeping the presentation in this fashion, like global and Indian road crash scenario and its comparison with Assam, because this particular NIT is located over there. Just I thought I will make a small comparison before going into road safety audit, history of road safety audit, and what are the various stages and contents of a typical audit report, and RSA conducted on the Greater Noida Expressway, which the case study which I considered, and also subsequent, because once when road safety audit is done, you need its implementation is the basic requirement. As we do a technical audit and compliance has to be there, like financial audit is done, you need to show the compliance. Similarly, in this particular case, we just monitored the implementation through a research project. It's a dissertation project rather. So we just did the implementation. After that implementation, we just try to evaluate the benefits of such an implementation in terms of economic benefits, and a brief on stages of that thing I already given there. And illustration of, I'll end my presentation with the illustration of typical bad and good safe practices about road design, road signages, road markings, and crash barriers from Indian roads. So, global road safety scenario says in 2016, based on the GRSP report, global research on safety scenario, they say 50 million deaths, 50 million injuries are occurring, and 1.3 millions have been reported in 2010, which has increased to 2016 to 1.36 million, and it's still kept on rising. So in 2011, considering this part, like on the 11th May 2011, they took a decision to call this decade of starting from the 2011 to 2020 as the decade of action for road safety. So the UN Secretary General took a decision that 192 countries participated, and it is supposed to bring down the endeavor is to bring down the crashes and the deaths at least by 50%, because it's not possible entire thing can be just like that removed. You can't really go about in totally full control of zero vision is not possible for the entire globe, across the globe. At least some meaningful target was set in 2011. And with that, they expected 5 million lives could be saved. This was the endeavor with which this projection was done. And but when we, as we go along, I'll just see how these figures got translated. You can see here also number of vehicles and rate of motor traffic per death per 100,000 vehicles. Even from 2000, if you see till 2016, the deaths have shown some sort of a stabilization, but it is not to the level to our liking. And despite the number of vehicles in billions has increased. So that is the 64 deaths was happening for every 100,000 vehicles in 2016. So though there is a 50% death reduction is there, but the target which was set up in 2011 was whether we are achieving towards the target or not, we have to see. As we see here, the death rate, if you see in terms of the road traffic per 100,000 population, it has remained almost static, like even from starting from 2000, and it's shown a minor increase rather. If you see in terms of the number of deaths and the rate of deaths. So though in terms of vehicular population, that's what statistics is one thing we can try to play around with. But it is not possible, like in terms of the actual deaths happening, it is not translating into the figures which is envisaged on 11th May 2016, 2011. So that's why seeing this particular decade is coming to an end, in the third global ministerial conference on road safety, that is, of course, the politicians rule the roast in entire across the globe. So they took a decision on themselves, the countries have not performed that well, because if you see a country like Sweden, they are envisaging for a zero vision. But a country like India or any other low income or low income to middle income countries have shown the increase only. So that increase has contributed. This low and middle income countries have contributed to this increase in deaths since 2011 in a more significant manner. That's why 90% of the deaths are happening in these kind of countries as compared to some European countries, or for that matter, to some extent, the United States of America or Australia, New Zealand, they are shown a reduction. But a country like Sweden, they are thinking for zero vision. But whatever may be the case, in the country is one of the best in the world, Sweden, in that meet, they took a decision, this decade of action for road safety, they extended the deadline of target of 50% reduction and serious injuries to 2030, because the figures were not showing any respite in terms of reduction. So having given this overall view of it, let us see what India is. Like India, in terms of the crashes in 2003, if we see, be it the fatal crashes or in terms of the persons killed, in 2011 we were something in the range of 1,25,000. So the lakh and 27,000 rather. So that has actually when this decision was taken, and at that time 50% reduction means we should have brought it something around the 63,000 mark. But on the contrary, we have seen that some fluctuation in terms of persons killed or in the fatal crashes, you can see, or the persons injured. So there is some sort of a dip could be there in persons injured, but the fatal crashes, that means that roads which are getting built has not been making it foolproof in terms of fatal crashes. More fatal crashes occurring, maybe as compared to the persons getting injured. And also, though there is some stabilization or some minor dip has happened in terms of the overall crash thing, but the number of crashes reduction has no way translated in terms of persons getting killed being addressed. That means if a crash is occurring, that is resulting in more number of deaths. That is what the scenario is in the India, which is the published data till 2018. So, and if you see another parameter which we tend to do it is in terms of the number of crashes, number of road deaths per 100 road crashes, which is which will give a more good picture. So if you see from 2005 onwards, this has shown the increase only. That decade of action for road safety, in that year we were something, let us say 2010, because 11 it was taken, 10 if you see, it was 26.9. It has increased till 2018 to 32.4. It is mean 32.4 deaths are occurring per 100 road crashes. That also has not shown any sort of dip. And let us come to a comparison of different states in terms of number of road crashes. Though a state like Assam, which comes in the second rung of leaders in terms of road crashes, it falls in the 500 to 10,000 road crashes. So, but even then, it is if you see from 2017, it has shown an increase only. Something in the range of 7,500, it has gone up to almost 8,000 in terms of road crashes. So, yeah, and also you have to understand another fact here. Assam is one such state wherein it is, of course, is the gateway for the northeastern states. From whatever my visits I made to some of the northeastern states, like I find though it is recognized as the gateway for the most of the 8 northeastern states, but the vehicle kilometers of travel in the state of Assam is not that great. But still, it is contributing in the higher end in terms of the crashes. This could be one major reason. Could be many of the roads in the northeastern states or any of this have rolling terrain or some hilly terrain roads wherein its crashes are occurring. That is the important. That means the safety parameters have to be addressed in a more intense manner. And if you come to the number of road deaths, it was 16th rank in terms of crashes, but it has shown in terms of deaths, which is around, it has also shown the increase. Something in the range of 2,500 has gone up to 2,700. So that is the level of crashes which is happening and the deaths which are happening. And in terms of the same parameter which I just now told, 32.4 is the national average, whereas the crash severity of index of Assam almost identical to the state average. So national average. So which is somewhat at par compared to some of the other states which are performing much more worse. That's what I told you here. Vehicle kilometers travel in Assam is not that great. So that is one of the major parameter in terms of crash deaths happening for 100 road crashes is not that high. That means number of vehicles on the road is relatively less as compared to a more industrialized states like Maharashtra, or for that matter Tamil Nadu or Andhra Pradesh or like Karnataka, like that. And the trend of road crash severity, if you try to see how it has gone, It has, that is again a good, this is somewhat a good point. We saw in the previous slide about the crashes have increased from 17 to 18, but it has not translated into deaths happening per 100 road crashes, has shown a minor dip of around 1.2. A value of 1.2 has shown the decrease, which is somewhat good. And this is in terms of million plus population cities. Interestingly, this city of Guwahati, which is having million plus population, it doesn't figure in this list, which is really somewhat good. Like maybe another parameter is if there's more congestion is happening on that road, may not be resulting in one of the worst crash severity city. That is a possibility. But except Guwahati, there is no other cities there in Assam. So having told you about the different parameters, how road safety audit as a tool can be used, how this has evolved, I'll just tell in a couple of sentences. Basically, the history of RSA dates back to 1980s when the county survey, they were building newly built roads because Department of Land Transport is the whole and sole authority for the United Kingdom roads which are getting built. So they felt, despite going in for a thorough design of roads done by the department, the number of crashes were showing some sort of a increase. So they felt that need to be analyzed by, they felt a policy was developed requiring design to be checked and approved for safety by the RSC team. They made initially a term called Road Safety Engineering Team, which will revisit the designs before a formal thing. So since it became a formal sort of a document which need to be done, essentially to be done, they made it as a road safety auditing, as the term road audit was attached to the thing for a thorough and detailed examination of a road design from a road safety perspective. That is purely road safety perspective. They will just look into the thing. The team will, which is a team, which is a minimum 2-member team, they are supposed to do. So similar procedures have been followed by British road agencies since then, and many of the countries have come out with their own manuals because there is a case for each of the person, because some countries have real preference for some sort of mode. So for example, Denmark and Sweden and all have, Netherlands and all have lot of cycle tracks. So that need to be given the special attention. So that way everybody try to develop this road safety audit in their own perspective. So like that, it branched off into various places. In India, first manual got developed in 2010. Prior to that, people were following road safety audit, but were by evolving, taking it from the other countries thing. And the CRA also has done some road safety design manual at that time. That was actually referred to. But officially, IRC published 2010, and which were revised it in 2019. So North America, like the United States of America, also started following it in 1996. Now everybody are having their own manuals. So the road safety audit process and stages, basically, is prevention is better than cure. With that particular thing only we are doing. Safety audit seeks to minimize the risk of crashes occurring as a result of changes to the highway. And main focus, as I told you initially, that survey example, they felt that those locations, these crashes are occurring, and that's why they revisited it. So they felt the design aspect has to be revisited purely from the safety perspective. So the safety perspective is in specific context, highlight the needs of vulnerable road users like pedestrians, cyclists, two-wheelers, like that. That has to be given the due importance when we do the audit. Road safety audit is what it is. It's a formal process, not an informal check. That's why the team of people who are involved, they need to sign that report at the end of the day, and it should be conducted by persons who are independent of the design. So that is also important thing. I hope I'm audible. Hello? Hello?
Yes, sir. Yes.
Yeah, audible.
Sir.
Yeah, conducted by persons who are independent of the design and conducted by persons with appropriate qualification, training, and experience. In IRC SP 88, we have brought out the revision, what sort of qualification, training, and experience are essentially required, and it should be done as a it's a assessment of road safety issues in a road design, a traffic management plan for road works in the case of any construction driven works, or a newly completed road scheme. If it is a road which is about to be opened, we can do exclusive pre-opening audit also, or it can be the identification of safety measures on an existing road. That is the existing road audit. Minimizing the likelihood of crashes occurring through safety conscious planning and design, and it is ensuring that a crash occurs because error is human. So that way, if anybody makes a mistake, the likelihood of the crash is minimized. That is the important point. We are supposed to address it by providing what sort of measures in terms of anti-skidding surface treatment or crash barriers, or ensuring that safety-related design criteria are met, and minimizing the risk of crashes on the adjacent network, because intersection is one such thing need to be given special importance when we do the audit, because as per the crash data published by Ministry of Road Transport and Highways, which I showed initially, at least 48 to 50% of the crashes occurs at the different forms of the intersection, starting from a unsignalized intersection to a roundabout. So different type of intersections contribute for the thing. So you need to give proper attention to the safety parameters. Adequacy of the safety parameter has to be assessed from the by considering interest of all type of road users at that location. And road safety audit is enhancing the importance and relevance of road safety engineering in highway design work, and enhance the consideration of the safety of all road users, which I keep on emphasizing in all new and existing schemes. At the same time, road safety audit is not a check of compliance with standards alone, because we have host of IRC standards available, a host of IRC manuals available. It is not that you have to just comply with the IRC standard. So, for example, if I am trying to tell a crash barrier to be at a certain location, that if in the IRC it is given every 3 meter and above only crash barrier is required, which is may not if the same location is located on a curve. This particular standard, if in fields, there is lot of crashes are occurring, and this can be avoided by providing a crash barrier on that runoff type of crashes can be controlled. Then you need to go beyond the standard. That's what it is, not a just check of compliance, because the standards are given for a ideal condition, but it's not that location. Depending upon the audit visit, if the team feels certain location need to be given beyond what is prescribed in the standard, that need to be given. It's not a substitute for regular design checks. It is not a crash investigation, because prevention is better than cure. And also, it's not an opportunity to redesign a project, which needs to be carried out separately. So, for example, if a junction is having problem, the safety auditing team at best will give a conceptual design. In terms of a full-scale design, by having the AutoCAD drawing prepared and made for that, conforming to the right-of-way availability at that location, has to be done by the team by giving out a work separately. It cannot be combined as part of the road safety auditing work. And it's not a name for more detailed site inspection. It is basically it's a formal inspection of the road and trying to understand the safety perspective. And it is not to be used like one rating a project as good or bad. It is not that way it is to be done. And it is also, it's not an ego of an individual. Say, for example, some fantastic design is given by a design team. It could be a 2-member team or 3-member team. So that we are subjecting it to a review of it from the safety perspective. So here there is no question of ego of an individual or a team is coming. It is basically we are trying to address revisiting that particular road from the safety perspective. And it's not something to be applied only to high cost projects or only to projects involving safety problems. It can be applied to even to a bicycle routes. So USA is one such country, joined this particular bandwagon of road safety auditing late, but nowadays many of their city roads wherein bicycle routes are there, they get it audited. So it's not that it should be applied only to an expressway sort of project. It's not an opportunity to raise subjective personal concern. The stages of audit, feasibility of preliminary design stage audit, detailed design stage audit, construction stage audit, pre-opening audit, or road safety inspection we call, because the road which is already operating where there is lot of crashes are happening, that is called it can be also called as a overall as a road safety inspection, or we want to say from the RSA perspective, you can also call it as operation and maintenance stage RSA. But in Indian context, as far as our knowledge goes, many of the audit have done starting from detailed design stage, and it might have gone beyond that to construction stage at periodical intervals doing, and pre-opening stage before the road is open, and it may end with the final road safety inspection. Where there is a crashes are occurring more, people may do O&M stage audit for that road. And preliminary design stage, why in India this kind of audits are not done? Many of the plans get shelved after some period of time. That's why these audits are rarely done. Who does the audit? It should be effective. The safety audit needs to be carried out by specialists who are independent of the design process, so as to take a fresh look at the project focusing on safety. Audit team should possess expertise and experience in road safety engineering. What type of project? I already listed you. It is not that it should be only expressway or anything. You can do a even low-end project like a pedestrian or a bicycle routes also can be audited. Even as specific intersections which are having problems, they can be specifically audited. And road safety audit combines art with science. That is the art of assessing how the road user will use the road and the science of proven road safety engineering principles. Basically, the key audit steps are selecting the audit team, that is the client or the designer will do it. Say for example, client means the road owning agency. Designer means it can be this person who is in charge of the road, like a concessionaire, and provide the background information that is responsibility lies with the designer. If the designer happens to be a client, then he can also provide. Hold the commencement meeting. That means client or the designer will do the thing with the audit team. They will assess the document. I hope my mouse moving you are able to see. Hello? Are you able to see my mouse movement?
Yes.
Yeah.
Yes.
Assess the documents. Thank you. Assess the
Dr.
document.
Murugan,
Yeah.
we are in touch. We are in touch. Please continue.
Okay. Yeah. Assess the document. That is, inspection of the site will be done, and the audit report will be done, and the completion meeting is held with the client or the designer, and the response is finally written. After the completion meeting, the response has to be given by the client or the designer, and the changes implementation lies with the designer. In that, or otherwise, if client himself is the designer, then he has to do it. The contents of audit report: a title page, the name of the project and its content, a brief description of the road project, what type of project, why it has been proposed, and the stages of the audit, names of the road safety audit team members, the date of the audit inspection, and the weather conditions on site at those times, a table of safety concerns found from the desktop audit as well as from the site inspection, priority rating for each safety concern, and practical and clear recommendation for corrective action for each safety concern. So basically, digital photograph, that is the major, and with the date stamp, that is the important thing. And of important safety concerns linked or aligned with the road chainage as far as possible. Because in urban context, this may not be possible chainage, but in that case, you have to align it with the landmark. But otherwise, in inter-urban roads, any type of rural highways or inter-urban roads, chainage will be the best way you can communicate with the road engineer or the road owning agency or the concessionaire very well. So that also, there's a photograph should be aligned with the digital photograph, which is a time stamped digital photograph, should be aligned with the chainage. And also, if you can take with the GPS GIS data, that will be fantastic. and a statement signed and dated by the team leader on behalf of the team, indicating the team has audited the drawings, inspected the site, and identified the safety concerns noted in the report. List of all drawings, reports, and documents is need to be mentioned. This may be useful for later because somebody has referred to certain drawings and reports that should be given. It may prove as necessary at the later time to be quite specific about the actual drawing and design report that was audited. The audit team leader ensures that all audit recommendation audit report indicate the direction in which a solution should be sought rather than specifying the solution. If they become too prescriptive, they become impractical. For example, during a design stage audit, the audit team discovers a steep side slope beside the national highway. The slope in such path is perceived to be dangerous. Let's say this example that I should have gone here, sorry, then I'll come back. Identifying and reporting the safety concern is the first and most important thing for the audit team. That whatever problem we say, being too specific with the recommendation when there are several options available can lead to difficulties. So in such cases, recommending to the project team to install cache barrier will often be as too prescriptive, and some situation may not be technically sound recommendation due to issues that are known to the audit team. So they may. So if the project, say for example, is at the design stage, you can say ask the people to flatten the embankment because instead of installing on a crash barrier, which is going to be a, of course, embankment is a somewhat cost-sensitive solution, but that will be a long-term solution. There will not be any since the embankment is flattened, which will be the first option. In case of a non-availability of right-of way, you can go for the crash barrier. That is what it is expected to be done. I will come back here. This by mistake, this particular slide has come here. So whatever I just told you this example, but what does the report contain? The report contains observation, reasons for concern for that location, supported picture to appreciate the gravity of the issue. Audit team recommend the road safety engineering measures for each observed problem. Audit team will also set priority level, urgency with which each recommendation has to be complied with, such as highly essential, highly desirable, or desirable. Coverage of the audit, what all we cover in the different sections: general information about the road section, cross section, alignment, interchanges, junctions, provision for vulnerable road users, road signs, markings, lightings as per standards, provision for roadside communities and roadside hazards. So suggested stages of RSA is, as I already told you, planning stage, only expressway we can do it. Remaining things can be optional and local streets not required. Whereas in DPR stage, even the Supreme Court has come out with the ruling on 30th November 2017. Any road which is the length is more 5 kilometers or more has to undergo one-time design stage audit. So that way it has been clearly spelled out. So you need a design stage audit to be done for any of the one-time design audit. You need not have to do for a road, rural road, remaining things. But at least you need to do a one-time design audit. That is the important part. And construction stage and things like that has to be done for expressways. And construction stage RSA is done at periodical intervals. It's not that you need to do it. You can do it once and leave it. You need to do it after. Generally, the periodicity will be between 3 to 6 months, depending upon the length of the project. And pre-opening will be one-time audit, and afterwards, existing road according to the policy, local policy and resources available. In terms of crashes to be addressed, you will do the existing audit. And then the national highways also similar kind of scenario is given, and state highways also. In MDRs, construction and pre-opening can be optional. Urban roads, certainly you need to do design, but for pre-opening is a must. Construction can be optional. And local streets, you need to do only design as a must. Remaining two can be optional. So issues that will be addressed related to the commuter safety, this is are the things you are supposed to address it. So now I will come to the case study of simply I'll just explain what's the road safety audit we applied for this design audit, existing stage audit. This is a 2002 built road. So we did the audit in 2013. The road starts at the outskirts of Delhi, It's a 8-lane divided expressway, which is having 5.5 meters of median, and it starts at the one place called Mahamaya flyover and ends at the Greater Noida at a place called Pari Chowk. But the first 20 kilometers, the Noida Development Authority asked us to do the audit. So that's what they initially approached us with the central wedge aesthetics improvement. We impressed upon them that audit is the way out, and we will give you a comprehensive solution like that. So we did the audit, and the relevant traffic studies were done, and traffic road crash data was studied, and the speed profile data was done. This is the typical way we just went about in doing it. You are supposed to do it in this fashion. And so what I'll just go into the what we did and what finally got implemented. About 70% of our things were implemented. So one of the I will tell you what are the points which got implemented. The brief status on the project corridor. It is if you see the median width I told you is about 5.5 meters. It is having this kind of barbed wire fencing, having this concrete poles which are there. So which is actually a safety hazard. So we asked them to make it. At that time, tri-beam was not available in the market. So double rows of W-beam we asked them to put. That has been erected on the ground. And similarly, this it's an expressway. I told you. Expressway means you need two types of roads: acceleration lane and deceleration lanes. Both are called auxiliary lanes. Both are in a together called. So this was missing here. So there is no acceleration lane of 75 meter and straight section of 95 meter and tapering length of 55 meter was missing. So we asked them to put it. So that has been constructed here. So that way people will be in a position to either exiting their 8-lane divided road or entering the road, they will be able to do better. So 3 locations. I am giving you one location thing. Another location also I'll give here. So like that, these kind of issues were given for different locations. And another thing is, it's an expressway. You are not expecting pedestrians to cross. It's an urban expressway. They have a speed limit of 160, 100 for the light vehicles and 60 for the heavy vehicles. And we asked them to put, because there are some institutional development is there and also residential development is there. So where there is a pedestrian movement should not be occurring on the expressway at all. That's why we asked them to provide FOBs at 3 distinct locations. They have constructed it along with the lift facility. And as I told you, it's an 8-lane road. We felt that this should be having some emergency lane. So that is what we asked them to put. This kind of road was carpeting was done in 2013. Then we went about in telling this need to be having this kind of thing. They implemented on the ground. The 14 meters of width, the last lane identified for the emergency vehicles, which was used by the 2-wheelers as well. Because the 2-wheelers are allowed on this road, because it's a free road and it's one of the major things. They wanted this thing to be there at every 3-kilometer interval. This is purely not a toll-free road. So that's why everybody are using. So like that, retrofitting studs were not there at many locations. We asked them to put it. So this is the scale of the thing. And also width of the service road was only 5.5 meters. We asked them to increase to 7 meters with paved shoulder. But finally, due to the constraints of land, they made it only 7 meters. This is what you can see. And there also that whatever poles which are removed from the median, they have been erected here. This is a road studs thing. Sorry, I just and these are the embankment issues which they actually done it. And also this aspect about variable message signs and installation of speed enforcement cameras, because people are violating beyond that stipulated speed. So that's why BMS boards which will display the things. For that, speed enforcement cameras have been erected so that people can, using the BMS board, and also challan first will be generated, and the offending vehicles information will also be displayed. Like that, these kind of things have been done in the control room. And the TPM, transverse bar marking of horizontal curve in the horizontal curves of 8 mm thickness has been implemented. You can see here. And this is the obscurity problem of the signboards that we asked them to address it. This is the thing. So having done it, these are the total costs they have invested, 232.8 crores. We thought this has to be, since such a huge investment was done in 2013, we did a small research work. So for that, we just profile of the crashes before the audit was done in 2013 beginning, and immediately they implemented the things. So this year we didn't, this year data we didn't consider at all. But before and after, we just considered 5 years before, 3 years after. So crash data was taken on board, and economic analysis was done by considering that total investment of 232.8 crores by inflation was applied, and we did the cost benefit analysis. So this is the research study, that cost benefit research study. What was done was review of the practices for evaluation of road safety audit and collection of the before and after data, and estimate the reduction in crashes, and to perform the cost benefit analysis using CRF, to estimate the benefits of RSA implementation using HDM4. So wherein myself and another colleague was involved in guiding. So here also, like what we did, the collection of data during the 13, same kind of data was collected at lesser time intervals, classified volume counts, spot speeds, journey time, road crash data, and severity, which you already saw it, which I just now showed. So this crash reduction factor was applied in terms of number of road crashes after RSA implementation and before RSA implementation. This and also since I told you already, traffic volume data was collected, and the kilometers of travel was taken on board, and exposure level in terms of crashes before and after were taken, and to understand how many crash reduction factor will have its impact. So that has yielded in terms of reduction factor to the extent of 0.42 is the decreasing trend since the implementation. So this was a crude method, I would say. Total number of road crashes which got modification and reduction which has happened in terms of the things was worked out in a crude manner. So with this crude manner, benefit cost ratio also yielded 7.22 and 8.96. We felt this need to be further done through a robust software like highway design and maintenance standards model of HDM4. So that is a version 2 was used here. And in this particular thing, we have, since we had enough data available in terms of the traffic volume, traffic speed, your road configuration data, since the 232 crores, how much is the amount invested for upgradation, for routine maintenance, traffic data, road network, accident data, all these modules, we had enough data available. So that's why we were able to use this HDM4, which is somewhat a robust software. Only limitation of the HDM4 is you need more data. Where as much good accurate data is you will get a better estimate of your economic analysis results. So this is the cost which has incurred towards the starting from the cost incurred for the variety of things like maybe the regular maintenance and things like that, or the ITS installation and DBM which has been put, track sealing which has been done on that thing, auxiliary lane, whatever the thing, and they were traffic signboard, side drain cleaning, and the BC course what they have put, and the auxiliary lanes which they have invested. Everything was taken from the, of course, this is the economic analysis. The cost has been considered devoid of taxes. So that's why economic cost was taken. So the various speed flow models for the traffic flow model, depending upon the, since Indo-SCM data also somewhat available at that time, we try to utilize that thing in terms of the capacity up to which the traffic will be moving. So that was also taken on board. But here analysis was done primarily for the crash thing, not oriented towards overall vehicle operating cost or time cost. That was not taken on board here. So that is the main thing, is that module which is available in HDM4 was specifically used to understand these factors, and running analysis was just done. And the road, in this case, road agency cost was taken for 15 years period, in terms of the road agency which is doing, and road user cost. Of course, the vehicle operation and the travel time cost are there, but the accident cost is the major focus here. we went about in understanding the importance of the road reserve cost. And basically, before and after implementation, you can see cost 5 years before crashes and for 3 years after. This was some sort of a substantive reduction was there. Of course, accident cost, as you know, will not be more than 1 to 3% out of the total road user cost. So that is the, but human life is involved. That's why this has to be given the due importance. So if you see the thing, we went about in finally benefits due to the RSA reduction. We just went about in understanding, do nothing. That would have been without the investment. I told you 232 crore was invested. So this is a do nothing thing. But after the implementation, what would have been the thing? But we have done it through the HDM. So that way, average traffic speed also has shown some sort of a stabilization, and reduction in crashes can occur due to this predicted road crashes after safety implementation. So finally, what we found was the IRR value as compared to the BAU scenario, business as usual scenario, was 23.1. Is the one in terms of economic internal rate of return benefits due to the present implementation. This is what we have just done for this particular case study. Lastly, I'll just give a very 2 minutes. I'll just go through the typical bad practice of road signing and road markings being practiced, defying Vienna Convention, not conforming to IRC 67. Incidentally, we are just revising IRC 67, which will be now followed under the further revision. Within 2 months, it will be published. So these kind of signboards should not be used. Even in our audit report, you must have seen when I was just showing the pictures. We asked them to replace this kind of boards. You need to have the no parking, no standing written separately, and no. If you want a definition plate, you can put it no parking, no standing. It is not only here; both is implied here. But this kind of background is not expected. Similarly, this kind of Delhi High Court is just to be written. You should not leave such a big space for keeping your organization NDMC here. They want to imply their logo they have kept. These kind of boards are, and also even this stainless steel is a wasteful expenditure. And this kind of, whatever in Delhi, unfortunately, we see all these things are non-conformity boards. You should never use it with the background. It should be without the background. And I'll see, since I don't want to end on a negative note, I'll show you some good practices of road design, road signages, road markings, crash barriers in vogue on Indian roads. Say, for example, these are all good boards which have been put. Of course, accepting that you did not have to use this much of the aluminium is the one which is aluminium, some particular material. I forget, not aluminium. Aluminium again becomes the vandalism thing. Some mixed with something has to be put there. So that is the material they have put, and this again not to be used here. To prevent road crashes, single way crashes, pedestrian-related crashes, crashes between vehicles in driving same direction, and what are the things? Say existing road intersection geometry. I told you audit can be done for an intersection geometry thing, which we have recently submitted to one organization. This particular thing we are given a holistic solution for this location, which is experiencing almost 25 crashes per year. So that was the level with which the things were occurring. It is the outskirts of Delhi, leading to Faridabad to Gurgaon road is there. So this location, that previous, you can see the same figure, how much it is transformed in terms of the traffic to be regulated, and also considering the various factors. We are given, and similarly, if there is a school zone is there, how nicely you can do a good design, which got instantly implemented also, one of the highways in connecting with Jaipur. So this kind of, if you design a roundabout or anything, or if the school is nearby, you can think about a solution which is more pragmatic in nature, so that you can allow this kind of designs to be there. So these are all the typical illustrations of road studs, how one can keep it on a divided carriageway, wherein if you are allowing a 4-lane divided carriageway, with the median opening having a minor intersection, how you have to do it with the flaring, without flaring. So if it is a right-hand storage line is given, how you have to really do the delineation and how the flaring length has to be there. All those things are given here, and how the things have to be done on the ground. Similarly, here flaring portion, how you need to put, as I told you, studs are expected to be put on the flaring portion as red as the edges and yellow as the this one median side. For the lanes, you have to put white. That's what it is. Here, it is green is given for representative purpose, but actually the white is the thing which is written in IRC 35. And this kind of hazard marking is one of the important concepts. We should really go about in doing it at locations where the pedestrian movement is there, and the people have to come out with the they have to be change in the type of marking itself will convey some message other than the speed limit sign, like this kind of things. And this kind of fixing of road delineators on sharp horizontal curve is good thing which are done in some of our roads. Speed hump is one thing which has to be done, designed to 10 centimeters. And this kind of installation of wire rope coupled with chevron sign. This is also a good measure which we can do it. And here again, this you can see on the chevron signs which have to be put on the curves, delineating the curves. And similarly, this kind of OHM has to be put. Minimum 4 OHMs are there required on a culvert thing, whether it is a divided carriageway or undivided carriageway. Minimum 1 on either side of direction of travel. Sorry, divided carriage, undivided carriageway 4 are required. Like that, here you are just given it here. And these are the locations where you can do the delineation, as well as nicely they are done at certain locations as per some of our roads audit recommendations. And this is again another good practice. They have done it on the road, which I just told you, red and yellow studs, which has been put on this one. But lower lane delineation, as I told you, white, that has been done. And this is again another typical measure which we can try to put it on the flexible bollards. We can use it at the urban areas when the road is passing through the relatively lesser speeds. We can think about putting it. And this is again the crash barrier treatment or the wire rope treatment we can put. And safety barriers, this is what there are 3 types of safety barriers which we have. And like median side safety barriers, and there is a horizontal curve. Considering that part, you are supposed to give it for the thing. These are the this is basically wire rope is fully flexible barrier, whereas the W beam is a semi-flexible barrier, and concrete cash barrier. I'll show this is a concrete cash barrier. So this thing W beam, you have the tri-beam barrier. This is a tri-beam barrier, and these are the various installations of different type of locations and good practices which have been done at certain locations. I just given here. And this again something which has been proposed in one other location. And this kind of you need not have to physically create anything. U-turn facility, you just create it with the. This is a ghost island that can be suggested at one other location. That can be a good way to give it for the when there is no when you are allowing a median opening for this purpose, you can give it. And this is a toll plaza locations, and also this is a Bain Bridge location. How nice we are doing it. That is also, this is what I just told you, good practice of what I showed you previous figure that has been implemented here. And this is again another location where it is implemented. Lighting is one thing when it passes to urban area is a good practice. And this kind of service road when provision is there, how much you need a delineation, that is also given here. And signs as to be, these are one of the good signs in Delhi also. We have conforming to this IRC standard, and similarly another good sign conforming to IRC standards. And these are the various type of studies we have done. I will not go into that part, but just I want to tell you, 15-day certification program is one thing which you have to think about people who want to practice. And also today, the director of NIT Silchar, Bandapati was telling that NHA is going to coordinate with the local faculty out there who have the good expertise about traffic engineering or safety engineering knowledge. they should also think about undergoing this 15-day certification course. Like we at CRA also do offer it. This April one has been postponed finally to November. That hope that we will be coming out with the final thing sooner or later. Like November, we will be conducting it. These are the references which I just referred in making this presentation. Thank you. Hello. Thank you. I completed.
Yeah, thank you, sir. Sir, just before taking over by Ambika, hello.
Yeah.
Is it visible, audible, sir?
Yeah.
Yeah, sir, I'm one of the organizer. I'm a
Yeah.
Sir, you have just told me about this 15-day certification course for road safety audit.
Yeah.
Please inform us the timing so that we can join your course, because already we have signed our MU with NHI. It's already in process.
Okay.
And 2 stress of road are already being offered to us. So it will be
then
great.
we should, November we are conducting, so you can think about joining for this course. Sir.
Yeah, thank you very much, sir. Okay, Ambika madam, please. Go ahead.
Ambika, I just took 5 minutes more. Sorry. Sorry.
No, it's not a problem, sir. So thank you very much for your indeed such magnificent session. So lots of questions are here. So,
Yeah.
sir, are you able to see the question?
Should I open YouTube in this? Here it is not coming questions. So YouTube it's coming. I feel.
Okay, no
If I open YouTube, I can see it, I suppose. I not open YouTube.
In the YouTube link, you can see all the chats.
But just now, in the meanwhile, you can read the question. I will just also open the YouTube.
Okay, sir. From Sagar Penjan. So in New Zealand in 90s, there are lots of accidents happen so that the people are using more number of bicycles than car or two-wheelers. And according to that, the developer developed road lane system, which helped in reducing almost 90% of accident, and also in low carbon emission. So can we at least try to achieve something like that in India?
Yeah, we can do it. These are all measures. It is basically we have to think about various innovative solutions, considering the people's needs and people's how the people are taking it on board. That way, New Zealand, as he has already pointed out, is one of the countries which has shown a progressive reduction in crashes and also the deaths. So such kind of things can be thought about, but it is not. Only issue is that government has to take the things along.
So another question from Anna.
Yeah, tell me.
Can we develop any app which connect with the vehicle, which can recognize the road accidents?
Develop app.
Yes.
Achha. What sort of app is possible? I am not able to understand. Is it the app through which, like after it's for informing the presence of the location? Like a crash has occurred at a certain location. Basically, crash is coming under the purview of the your police. So app, what app is meaning? I'm not able to understand what app.
So can any app just look Google Map like this? Maybe some app we can connect with the vehicle. If that road accident happened, then it will automatically recognize with that.
I don't think so. Like that is a possibility. I'm not able to. I don't think that is possible. Like where is your YouTube thing? I'll also say. Yeah, I'm seeing here YouTube streaming. That it is there. Like,
Yes, sir.
No app. Yeah.
You're able to see that chat, sir?
1 second. I'll close that other one. Google. I will.
Yeah.
Yes, close the Google.
Close the yes.
Yes, close the Google. So you will
Yes. Now I am there. Yeah, you start. I'll keep it disabled. Yeah, tell me your questions. Are you able to listen me?
Okay,
Yes,
sir.
sir, you
Yes,
are
yes.
audible. You are audible.
Yes, sir.
Okay. You are asking me to see there, right? Yeah, like that one. Explain that there is something is written here about. Are you able to listen?
Yes, sir. Yes, sir.
Yeah. Many people have raised about the yellow color for sharp contrast for. No, yellow color should be the one which should be used for the. Uh, he means stud, I suppose. Somebody has written about the stud. Um, Now, somebody has asked about extra lane provided for you, U-turn or implemented in India. It is very much there. I showed the picture also. Sujit Sagu has written, are those extra lane provided for U-turn or implemented in India? I showed the picture also, no? U-turn provision. Are you listening my voice?
Yes, sir. You are audible, sir.
Yeah, yeah. Somebody like divider marking. Somebody has written about. Integrated road accident database. Integrated road data accident database is basically one ministry. See, two people have implemented this part. Somebody Satish has asked in the state of Tamil Nadu and also in the state of Himachal Pradesh. They have gone in for tablet-based recording of the crash data. So the police will record the crash and within 24 to 48 hours, the concerned road owning agency engineers will visit the site if it is a fatal crash to understand the causative factors. So they will also record it, conforming to IRC 53. Huh? Anything other than that? No other form I'm seeing, Ambiga.
So,
No
Mohammed
other
Hassan
questions,
asked
sir.
that what
Huh?
could be done? What could be done in the area where accident data are not available, since there is the case in most part of the country?
Yeah, it's a very good question. Yeah. Anything else? Is that much only or more?
Or
In that question?
yes,
Yeah, I will answer this question first.
yes,
Basically, any road owning agencies cannot go about in collecting the crash data. Only in concessionaire-driven projects, which is maintained by the your road by the BOT projects or HAM project, where HAM means hybrid annuity model project, where government also invests. So in these two type of projects only, that is about 27,000 kilometers of road. There is somebody is there who is there to actually get the crash data collected, other than the police. He will be the first person, the custodian of the road. That means the concessionaire will reach the location first, and he will collect it as per the format. That way, there is some sort of uniformity in data collection could be there. But accepting this 27,000 kilometers, and 5.8 million kilometers of our roads. They come under the police only are the only people who reach the site first. So we have to believe only on those data. And there is one school of thought which says the number of crashes which is reported is 1.5 lakh could be as high as 2.25 lakhs. But that could be that is the GRSP report. But which is how far? But the crash deaths which we are 1.5 deaths, 1.5 lakh deaths could be as high as 2.25 lakh deaths. That's what they were telling. But the death is actually getting reported by the only the police. The police is the only data source available for you. Whatever they get recorded, generally you can expect 90% of the fatality gets recorded. Only some minor injury and serious minor injury or some injury which is perceived to be minor injury could be a serious injury later. Those records may not get reported. Excepting that fatal crashes, everything gets reported. So that way, not a problem. I would still believe whatever the 4.6 lakh crashes which is reported by the Delhi by our police are reasonably good data. We can't have any other source for all our routes.
So another question by Anna, that if the available data of accident is not occur, what will we do? If yes.
Can you repeat?
Yes, sir. If the available data of accident is not occur, what we will do?
That's what law enforcement agency is the only data source for us. If that data is not recorded by them, then we can't do anything. This, police, somebody has written police difficult to get the data, but it is their responsibility to share the data. Only agency where from the data gets collected is police, but only issue is they don't maintain it on a online portal, which somebody has asked. Mr. Parmar has asked this question, but that kind of maintenance on the online portal, somehow they are not doing it, I would say.
And again, another question from A. Srivastava. Explain solution highway. There is no arrangements. If the vehicle is
kindly repeat.
Highway, there is no arrangements if the vehicle is damaged or no petrol or diesel.
Yeah. See, basically, as per the ministry or IRC's guidelines itself, you need to provide a fuel station at every 25 kilometers and a rest area at every 50 kilometers. That is the norm. And if that is unfortunately in some of the states, that is actually not followed. Fuel station is an important thing which should be available, is not actually provided by the road owning, contract has to be awarded to them. That's all. It's not the question of the government is going to invest anything on that. Basically, they have to go about in allocating the things and then go about in doing it. And one thing which is written here is, can't we see any surveillance system to record accident by using CCTV? CCTV cannot be put at each and every location, first of all. Even in a country like the United States of America or Australia, which I have happened to see, or United Kingdom, who are pioneers in road safety, nobody puts a CCTV at every 500 meters. It happens to be at critical locations only. And it's not possible through a crash. If the crash occurs at the critical location, then it can be certainly used. But crash data reporting is only through a that ambulance has to reach, and this thing, especially police have to reach. Somebody has written about use of big data analytic techniques. Can it improve the road safety to road users? I'm not sure big data analytics can play a huge role. As I already told you, this is not like you can't really go about in putting the survey. Big data analytics requires some instrumentation to be put on the ground. There is no instrumentation available on the ground. That is a huge investment. And somebody has asked, can we learn HDM4 software? HDM4 software is basically, it's not a 2.0 version is available. Only issue is that we at CRA also every year we offer a course there. This time it should have been held in May 2020. 10-day program we used to have. That because of COVID we couldn't do it. And other than that, this 1.0 is freely available. 2.0 is, I suppose, is a priced edition, which is supplied by the UK firm. And somebody has asked about can we get the data properly? Damage only crashes since they don't normally get reported. Yeah, this is again, it gets reported unless always the vehicle has fled off the scene, nothing can be done. If you have only the camera installed at that location instantly, we can have it. And somebody has asked, can we think about lower speed breaker or separate lane for ambulance? Yeah, this is a good lower speed breaker. The speed breaker has to be installed as per the IRC standards. And that too, speed breaker should be put only on the joining road, minor road. On the main road or highway, you want to control the speed, you can think about having TBM, transverse bar marking, measuring up to 8 to 10 mm thickness. And separate lane for ambulance, certainly in urban areas it's possible. It need not be, it is a thought process they should have. But unfortunately, because of paucity of thing, they are not doing it. And Anna Agna Varghese, can we classify the lane according to PC of the vehicle? Maybe it reduces road accident. That is one such thing. In Malaysia, they practice it. They have two-wheelers dedicated lanes and all. But in Pune also ran it on certain locations, but it was not successful. That can be an option in urban area. We can have it. What she says. But how much it will have impact on the road crash? Certainly, it will have some impact that need to be possible. That is, it's not that is not possible. Explain how some new arrangement in smart city which provide every data like accident, bad weather, nearest police station, petrol pump. This is again a smart city is one thing. Everything they try to say under smart city. It is not that possible. Like everything, whatever you see under the sky has to come under smart city. Because as I was told, the first round of smart city is mostly focusing on the other infrastructure rather than road infrastructure. So I'm not sure how much we can really address under the smart city program. I hope Ambika answered all the questions, whatever I'm seeing. Have you got any other question?
Yes, sir. How IoT can be used for road safety? Last question.
How IoT?
IoT.
IoT. Achha, Internet of Things. Okay, okay. IoT. Yeah, it's a good question. IoT is one Internet of Things can be used at least for. That's why I'm just trying to tell. At critical locations, you need to have surveillance in any form. The speed enforcement or anything of the sort should be there, and that should be with a fast, good bandwidth connected thing. Should be connected to your control center, so that the strict monitoring of the locations can be there. It's Internet of Thing is a generic word. In Internet of Thing, anything can come. Whatever have the best bandwidth to be provided for you to give connection to the service center, such kind of things can you do it. Redisa was joined. Did you consider segregating two-wheeler traffic from the expressway? Yeah, Redisa was just our guru. So he has just joined here. So basically, in this is the important part. We should address it, as he is saying. But in the scope in which we have done it, we have only earmarked that emergency lane to be used by them other than the emergency vehicles. That is what we have done. But as I told you, that two-wheeler segregation part is not considered here. Of course, it's more of a traffic management perspective. We are supposed to look into the thing. We have not done it. And Mr. Aditya Ghosh, divider marking color code is yellow and black for expressway. However, it changes when we enter the arterial road of city. There for some cities in India, is there any codal provision for this color change? Color code for national highways is yellow. That's correct. And arterial roads, there is some confusion what you are telling. For arterial roads, the board perspective, we are having blue in color, blue. And for the, if it's a national highway kilometer stone, it's yellow in color. And with the same national highway, which is informatory board, it is green in color. So that's what we follow it. That is a codal provision is given like that. So if it is an urban area road, that comes under the blue color. That's what it is. Aditya Ghosh, I hope I answered your question. That is one very good question Satish has written. See, the accident, I didn't, because of paucity of time, I didn't try to tell, because some of my data also there, accident word is there. But just I want to emphasize the fact, in 2011, when this decision was taken, one of the decision was because accident, the word attaching it to the road related events, they wanted to done away with. They wanted to call crash because accident word is unexpected turn of things which will happen. So that's why that word, instead of accident, they wanted to use the crash by meaning thereby the crash, road crash means you are providing the best engineering feasible for that location. Even if that, in spite of that crash, any this kind of event is occurring, let us call it as a road crash rather than calling it as a road accident. That's why, but in India, we unfortunately still tend to use the word road accident attached to the road related events. But as per the international terminology, we should call it as road crashes only. Even the new documents which IRC is bringing about, we are avoided that word, usage of road accident word in the IRC new document, be it IRC 67 which we are revising, or any other document recently which is going to get cleared. That is it. Anything?
Yes, sir. Yes, sir. Almost all the answer also we are getting from you also already.
Yeah.
So thank you very much for your informative session.
Yeah.
Yes. So.
Okay. It was a nice session, sir. Thank you very much. I think anything for tomorrow.
Yes, sir.
Yeah, actually, Redizar was finally written. Congrats to the organizers of the webinar. I advise to extend the expert lecture to your students from experienced experts. That's what he has written. He was our scientist, data gate scientist at CRRI. He retired in 2006 from CRRI.
Okay, sir.
Okay, thank you, sir.
Thank you, sir.
Okay.
So
Shall we close now? Shall we close?
Yes, sir.
Okay. Thank you, Ambika. Thank you, Dr. Ali.
Thank you, sir.
Thank you, Gina. Thank you.
Thank you so much, sir.
So with this, we come to an end of our first day of our 5 days webinar session on modern trends in transportation system. I, on the behalf of all the coordinators, would like to thank and express our profound gratitude to the experts for sparing their times on this webinar and grace the session. It feels honored to hear from you all. I would like to thank the participants for their willingness and involvement. I once again want to state that we are grateful to all the speakers for being with us. It has been a great pleasure. So see you tomorrow at the same time around 10 a.m. Good day.